So far, the examples that we were taking was all within the same package. So we didn't have to import it. Now I'll just show you an example wherein you would have something that is outside the package, and I'll show you how to access it. So we have to import it. So whenever you have it in different package, then you have to import that particular package within. One thing is importing the entire package. The other one is importing a particular class. So in this case, you have a package demo, and we can see that within package demo, there's a pack demo, which is nothing but a class defined within it. So let's see how to access package from another package. You have a pack demo here. That's a class that is defined within the package demo. As you could see here, there's one method which is msg, and which is taking two parameters as input, integer I and integer j. So what are the ways in which you could access this particular class that is pack demo from outside the package? So the first thing that you could do is you could import the entire package itself. So demo.star or demo.asterisk, as you could see here, which says that all the classes within this particular package can be accessed from this particular class. So you have a package demo class defined here which says import demo.star, and which would import everything, all the classes within demo. So in this case, pack demo, you could see that pack demo class could be accessed from within package demo class that's there in different package. So basically this package demo class that you see here is defined in some other package. Other thing is, if you want to import just a class and not the entire package, you could do that thing as well. So here what we are doing is import demo.packdemo. So you're importing a specific class or importing a specific class and not the entire package. That could be done as well. And the third one is, instead of importing, you can do one thing. You can have fully qualified path name or fully qualified name like demo.packdemo. That's your class name. You can access it within your class. So basically you would use the fully qualified name. You might use it, you did not do it, but you might use it in case where you're just using it once within your class. But you would go with this options, demo.packdemo or demo.star, in which you class has multiple, is referring to the class in different package multiple times. So in that case, you just do it once and could be used within your class. You need not do it again and again. So I create a new class which is com.edureka new dot. So I created a new package. So there's one that is com.edureka and the other one that is com.edureka new. These are different packages you have. If you want to use something within this package com.edureka, suppose I want to use vehicles, right? So this is what I was talking about. When you try to access it, you can't do it. You can't access vehicle from here because it's there in a different package. Now you are not able to access it because you haven't imported it. So what I do here is import com.edureka.vehicle. Once I do this, I am able to access it now. Now what I was saying is, if you are accessing multiple classes from multiple classes within the package, like car also you are accessing. So instead of writing it like this, so what you would do is com.edureka.car. Now the compilation error has gone. So basically, instead of doing this, like instead of writing it multiple times, the other option that we have is like com.edureka.star. So now if I get rid of these two imports, still it would work. I don't need these two imports because we have ported all the classes within the package. So it's able to access both the classes, vehicles and edureka, from com.edureka. The other one was you could get rid of this. Now it's showing up error. What you could do is com.edureka.vehicle. You could access it directly with the fully qualified name. So you can see the error has gone. So these are the three ways in which you could access different packages or access classes from different packages. Now let's understand what is a regular expression. So regular expression, pretty much similar to other languages that you have. Regular expression is nothing but an expression through which you could extract some sequence of characters from your string, or you could check whether a specific regular expression or whether a string is aligned to a particular regular expression. So you could define a regular expression saying that, say for example, email ID, right? One of the use cases of regular expressions could be like you have email IDs, and you might have seen it on websites wherein you do some kind of registration or something. And if you don't give a proper syntactic one, then what it would do is it would give you an error at the rate gmail.com. If you don't give that, it would throw you an error showing that it's not proper. So it's not checking against the Gmail server to see whether your email ID is proper or not. So it is just checking syntactically. You might have seen it. So if you give a wrong syntactic email ID, and if you go to the next tab, if you tap to the next column or to the next space, what it would show is you haven't entered it correctly. So basically what it's doing is it's checking it against a regular expression. It has got a regular expression saying that this is how an email ID could be. It should end with so and so characters. It should be at the rate. It should have at the rate. It should have Gmail, or it should have some characters in between, then it followed by .com or something of that sort. So basically to have this syntactic this thing done, just to ensure that you have given it properly, you have a regular expression. So yeah, one of the use cases could be to have this pattern checker, usually to see if you're giving value which aligns to what is expected. So maybe other thing could be if you're typing something, or if you have been asked to put some amount, and if you type characters there, it would give you an error saying that it's not allowed. Those type of checks could be done through regular expression. Or if you want some value to start with a particular character and end with a particular character, you can check it against a regular expression. Regular expression is a pattern used for searching and manipulating strings. It could be used for manipulating strings as well. So one of the use cases is searching, and the other one is for manipulating. The regular expression either matches the text or fails to match. So basically it would validate and say whether it's a match or it's failing. So we call regular expression as regex, which is nothing but abbreviation for regular expression. So Java supports regular expression, and these are the classes that we have within Java, which is in java.util package. So remember we spoke about java.util package, which has got utility classes. So these are among them. So here you can see pattern class, you have matcher class, and you have pattern syntax exception. So basically if you have some exception, if it's not proper, then you would get some exception as well. So we would be taking an example to clarify what this is all about. So here are some matching patterns used in regular expression. So just about to read through it. So you have like ABC, which means it has to exactly match ABC. If the string that you are matching it against has the content ABC, it would match. When you put it into square bracket, which says any letter A, B, or C should match, any character, and again if there's a negation, if within the square bracket, if you have this negation mark which says that any character except these three characters should be matched. So if you put D, it will match. In the second case, if you put A or B or C, it will match. And here it would be from D to Z. If you put anything, it will match. Not just alphabets, it could be anything, any character. A to Z. So when you say A to Z, it says that we are giving a sequence of it, right? So we are saying from A, it's a range basically. So it understands range as well. So when you say A hyphen Z, which means that it is from A to Z. Here we are saying that any one letter or digit should be in sequence. So basically you could have uppercase and lowercase as well. Basically it is saying it should be in sequence. It should end with basically digit at the end. Dot is some kind of a wildcard character saying that any one character except line terminator must be in sequence. This one indicates beginning of line. So we say that line should begin with so and so. You could put some character here, and we can say that if a line begins with so and so character sequence, or whatever regular expression that we have put in, then the entire line matches it. The other one is end of the line, to check if any character present at the end of the line. Other thing is word boundary. We have an example about this, so which would give you a clear idea about it, but it's more about it cannot be part of a word. Here when we put slash b to the front and the end, or to the start and the end of a particular character sequence, which means that it has to be a separate word, but it cannot be part of some other word. Slash b to verify that any character is not present at the word boundary. /G to check that the character is present at the end of the previous match. Meta characters. So we have /D. Instead of writing 0 to 9, you could use meta characters /D to define digit. When you want to define non-digit, which is like you can see here, negation of 0 to 9 set, which is non-digit, which could be like alphabet, space, or anything, which could be grouped as /D. /S is a white space character. So space, tabs, and stuff like that could be enter for that matter is a white space character. /S is a non-white space character, which means it's an actual character rather than white space. /W is a word character, and slash uppercase W is a non-word character. We have quantifiers, which is a quantifier defines how often an element can occur. So star, which means that 0 or more times, plus, which means that it has to occur 1 or more times. Question mark is it could be no or just one time. You could mention the number of times you want a particular sequence to occur, which could be put into your curly braces, occurs X number of times. X, you could put a range within your curly braces, X comma Y, which means that it should occur somewhere between X and Y. So it's a range. You have asterisk question mark. It tries to find the smallest match. This makes the regular expression stop at the first match. So as and when it finds the first match, it would stop. So we'll have a quick demo on regular expression. So here, before we start off, we define a pattern here, basically. Then you could see it is basically saying from A to Z and followed by character, one or more character. Then we have a check here, which is nothing but a string against which we are going to check. First, we compile the pattern. This is a regular expression pattern that you are going to check against. So the first thing that we have to do is we have to compile this pattern to see if it's properly done or not. So first thing is to compile it against pattern, and if it's correct up to the mark, you would get the instance. If it's wrong, then there would be some kind of exception thrown. Then there's a matcher. So once you have the pattern, you do pattern.matcher and you provide the string against which you want to check. In this case, you have happy learning, welcome to Edureka is a string that's been passed. And when you do c.find, if this is fine, it would return the result true. And if you remember the while construct, it would get in only if this is true. So it's a loop. So it would basically iterate through, and you could see here that it's displaying all the characters. I'll quickly run this. Let's name the class as pattern checker. Now I write a main method. Now, if you remember, we had a pattern there, which was like A to Z followed by characters. Then we have string against which you want to check, or you could say simple string to check. So we just put this one. So once you have this string to check, now what we want to do is we want to compile this particular pattern. So what we do, pattern.compile. So one thing to see here is that's the beauty of using the IntelliJ or Eclipse. So you could see here this package has already been imported. When you use it, unless you have multiple classes with name patterns, it would ask you to specifically explicitly mention which one you opt for. But in this case, there was just one pattern class, so it imported it automatically. And we give the pattern here. So basically, if this pattern is correct, if it's rightly formed syntactically, you would get a pattern here, or it's not pattern, I believe. We have a compiled pattern now. Now what we do is we take this compiled pattern, and I think we have a matcher here. We get the matcher now. So matcher would check against string. So you have a string to check, which would give you matcher. So here it's asking me which matcher do I want. I'll select this one, and you see this one getting inputted here. So this is what we have done. We have compiled the pattern and we have provided the argument against which we have to check as a part of matcher. We get the instance of matcher. So everything is in terms of class. This is what object-oriented programming is all about. You have a pattern, which is a class. You have a method within pattern, which is compiling your pattern. So this is what object-oriented programming is all about. Everything is realized in terms of classes and objects. This is nothing but the object of pattern class compiled. So now what I do is matcher.find. I just print this one, matcher.check. So basically what we are trying to do here is once the entire string passes through, we are trying to get the substring out of it. So when we get the substring from matcher, you would get the string indexes, begin index, and you would get matcher.end as well. So when we run it, you should get appy, and so the first character would be trimmed off. So you could see first character being trimmed off from each line. So importing regular expression, we saw that java.util.regex gets imported. Then you have pattern, then you have string to be checked against. The pattern and the sentence which is to be matched are given. A to Z means any character from A to Z, and plus means one or more. The sentence check is checked whether it matches the pattern or not, and the strings from the sentence which match the pattern are printed. So basically here we could see that H is in uppercase and we don't have uppercase here. So that's the reason it trimmed off the first character. So basically if I add H here, now H would match as well and it won't trim H or it won't remove H. You should be able to see H as well. So yeah, as you could see here, you have H appearing as well. Previous case, H was getting trimmed off. So this one is for the word boundary. As I said, if you want to have something like you want to be sure it's a separate word and it's not a part of any word, you could put something like this. So basically what we can do here is, so we can mention here something like slash slash v and then in. So what we are trying to do here is, you could see here, what we are saying is we want a separate word as in, we don't want it to be a part of any other word. So here in learning, though you have in, it didn't pass it because it's a word boundary. Whereas in, which is a separate word here, it just passed this one. So if had I removed this one, you could have seen two ins. That's what I mean to say. So now what's exception? Exception handling is nothing but typically, so here you could see two ins. When it's slash slash b, it would be just the ones that are complete word instead of matching the word boundary. Let's talk about what are exceptions. An exception is an event which occurs during the execution of a program that disrupts the normal flow of the program instruction. So to give you an example, yesterday we spoke about arrays, right? If array size is 5 and if you try to access something more than 4, like if array size is 5, which means that the indexes range from 0 to 4, if you try to access something more than 4, like if you try to access sixth element within the array, it would give you an error saying array index out of bound. Or if a particular object is assigned null value and if you're trying to access that method within that particular object, you would get null pointer exception. Since it's not instantiated yet. When you instantiate it, that's when the object gets created. But if your reference is pointing to null and if you're trying to access something within that reference or a class, you would get null pointer exception. Similarly, you have like divide by zero and stuff like that. It's basically something that is not expected or something that would disrupt the normal flow of program execution. When an exception occurs, the JVM creates an exception object to identify the type of the exception that has occurred. So basically, within itself, it would create it, or the code would create it. So I can create my own custom exception tomorrow. If I'm writing an application, usually in applications, that's how we do. We write our own custom exceptions. I can define my own exception as well. If within my application something is not working or something is not running as I would expect it to, I would throw an exception so that within my application, it properly logs or it properly prints out in my console saying that this is the exception that's been triggered due to so and so condition. So an exception is often referred to as runtime error. So here we can see divide by zero exception as an example. Now there are different types of exceptions. First one being checked exception, the other one being unchecked exception, and the third one being error. So checked exception is something that happens at the compile time. What happens is when you have a checked exception, when you are invoking some method which is throwing a checked exception, and okay, I don't want to get into the catch block as yet because we haven't covered it. So this is also called as compile time exception. It means if a method is throwing a checked exception, then it should handle the exception using the try catch block, or it should declare the exception using throws keyword. Otherwise, the program will give a compilation error. Whenever there's a checked exception that's been thrown out in the sense not at the runtime. There could be methods which is throwing an exception. So whenever there's a checked exception, you have to ensure when you give a call to that particular method. Say there's a method X which is throwing some checked exception, From your application, you are trying to access this method X. When you try to access this method X, you have to ensure that you are taking care of the checked exception that is thrown from X. If you don't take care of it, it would give you a compilation error. When I say when you don't take care of it, how do you take care of an exception? That would be the first question that would have come to your mind. So when I say you have to take care is nothing but you have to catch it. You have to handle that exception. So try and catch is a mechanism through which you handle the exception. So what you would do is method call or the call to X, you would put it into a try block, and in the catch block you would say that if this particular exception occurs, execute this block of code. That's a handler for exception X or checked exception that is thrown from method X. So basically you write a handler for in the catch block saying that this is what I want to do when this exception occurs. Once you have that, when your program runs, even if the exception occurs, it won't stop at that point. It would go and check whatever is written and whatever piece of code that you have written, and it can continue from there on. It's basically a decision made by the developer whether to carry from there on or whether you want to break it there. Whenever there's a checked exception, you have to ensure that you handle it. Either handle it or you say that I'm not going to handle this. I'm just going to throw this off from my method or throw this off from the method where I'm executing this method X, which we spoke about, which is throwing checked exception. I can choose not to handle it and just to throw it off to the calling program, wherever the execution initiated from. So if you don't do that, you would get a compilation error. Unchecked exception, unlike checked exception, it's not mandatory that you catch. It's not mandatory that you handle it. It's a runtime exception. Basically, it could occur anytime and it's not mandatory that you go and actually handle it. So even if you don't handle it, JVM would be okay with it and it won't give you compile time error. So basically, these are nothing but runtime exception. So divide by zero that we spoke about is nothing but a runtime exception. It's not mandatory that you go and actually, handle it during the compile time. You can either handle it or you can leave it as is, and during the runtime you would get an exception. So compiler doesn't check for the unchecked exception. It's done at the runtime. Now error, these are exceptional conditions that are external to the application and that the application usually cannot anticipate or recover from it. For example, if stack overflow occurs, an error will arise. They are also ignored during the time of compilation. So even the error condition cannot be anticipated during the compilation time. It's done during runtime, right? So one of the classic example is the stack overflow, wherein say for example, you call the same methods like 1,000 times. Not 1,000 times is too less for the stack to get overflowed, but suppose you call it like million times. You call the same method, right? In that case, remember when I said when you give a call to the method, it goes to the call stack, right? We have a call stack. So it would push something, it would push a state of class, or it would push the properties that's been passed as an argument, the class or to the method into the stack. Iteratively, if you call it like million times, what would happen is you would get stack overflow, because basically everything would get into the stack and it would basically leave your memory overflowed, or even memory for the heap memory for that matter. If you create a lot of classes, if you create a lot of instances of classes, your heap memory would get overflowed and you would get out of memory error. Those are classic examples of error. So what's the hierarchy of exception in Java? When it comes to classes, you have a throwable interface, and then you have error and you have exception. So exception is further, it has got runtime exception. The other ones are the checked exceptions. So IO exception, SQL exception, these are the checked exception. This has to be handled if there's a method which is throwing one of these checked exceptions. You have to ensure that when you give a call to such methods, you handle it or you throw it from your method. To the right side, it's runtime exception. So it need not be handled. As I said, divide by zero and stuff like that would be runtime exception. Even array index out of bounds and class cast exception, arithmetic exception. Then you have null pointer exception that we spoke about. All these exceptions are unchecked exception, and you need not actually handle it during compilation time. So why to use exceptions? When we execute a given program, we'll get an exception. Exception handling is performed in order to get the output. So basically, why do we handle exception is nothing but to get the program going rather than breaking it at that point. Use of exception handling: process exceptions from program components, handle exceptions in a uniform manner in large projects. So basically, why do we do it? So it's done basically to get the process going rather than stopping it at that point. And you could handle it the way you want to. That's the reason you have this exception handlers. Give you a simple example. Suppose 29 by 0. What I'm trying to print here, result after dividing 29 by 0. So basically, when you run this, it's not showing up any compile time error. It's compiling fine. Now when I run it, since it's a runtime exception, it's compiling fine. But when I run it, let's see if it throws an exception. So as you could see here, it throws arithmetic exception, which is divide by 0. And this is happening at the runtime. That's why it's a runtime exception or unchecked exception. When a runtime exception occurs, program gets crashed and control comes out of the program. As we saw here, when we ran it, it didn't run this part of it. You could see that it broke out just right from here. So whenever there's an exception, if you haven't handled it, program control would come out from there. Exception handling is done to execute the program without getting an exception. So handling is done basically to handle the exception. Whenever the exception occurs, do some action. It provides flexibility to the developer to handle it the way they want to and get it going. Mainly try, catch, and finally are keywords for exception handling. So we have a try catch. As I said, there's a try block wherein all the suspicious one or wherever the exception you think that there could be exception occurring could put it into a try block. And in the catch block, you would say that if a particular exception occurs, this is what I want to do. All right, that's the catch block. The finally block is nothing but no matter the exception is thrown or not, the finally block is going to execute at the end. So basically, finally block is usually used to release resources, right? When you deal with databases and stuff, you create connections against database, or you create some socket connections and stuff like that when you do some socket programming. Finally would be a place wherein once the execution of the method is done or execution of something is done, you say that we can release these resources off rather than still establishing the connection, right? Which takes up some of your resources, CPU resources, or which takes up memory. So basically, it's to release off the memory. Exception handling. So let's talk about try. Try block is nothing but code that could generate. So suspicious code, as I said, that could generate an error is written into the try block. So the catch block would be more about catching a specific exception and doing something with it. So you could opt out to just break at that point or do something with it. Say, for example, you want to profile an application or you want to have some instrumentation set for the application to see how much time, what are the exceptions that occurring during runtime, right? If you want to see that, maybe a typical way in which it is done is you write all these exceptions into a database and wherein later could apply some analytics to see what kind of errors have occurred in the application. You could see that later on. So that one of the use cases wherein you handle it whenever there's a particular exception, you put it into a database, you make an entry in the database saying that this is the exception that was caught in so and so time, and you could later on have some analytics to see how it could be improved, how the application could be improved. So finally block is nothing but whether successful or unsuccessful, the block is going to get executed. As I said, this is nothing but mostly it's used to release resources such as connections and stuff like that. Let's see a demo of how we can handle exceptions. To give you an example of try catch, say this is a suspicious code which we are running. Maybe you could put this into a try catch block and say when there's any kind of arithmetic exception that occurs, you're just printing it out. Printing any kind of arithmetic. So what we are doing here is nothing but we are catching exception and we are printing it. So everything is in terms of classes again. See, exception itself is a class. So you could click on it, control click, and you could see it as a class. This is a source code for arithmetic exception. So you could see extends runtime exception, which means arithmetic expression is a runtime exception. So it's a subclass of runtime exception. You could see super and everything being used here, whatever we discussed about. So arithmetic exception is nothing but it's a constructor, right? And you could see super being called here. So that's how you could get into exception and you could read through it to understand how the source code is being written. That would give you a good idea about how flexible Java is. It's very much when it comes to flexibility and when it comes to object oriented paradigm, it's very much cleanly followed code. So you could go and actually see it the way the programs are being written. If you remember when we did 29 by 0, the program broke. It came right from there and it didn't execute the following code. Now we have handled it. We are saying that whenever there is a arithmetic expression in this piece of code that's here, we are saying that whenever there is an arithmetic exception, we are going to just print it and we are going to continue it. Don't stop at that point. So you could see here the program didn't break, right? It gave you an opportunity for you to actually handle it and it didn't break, it continued. So you could see this statement's been executed as well. That's why you have this results. So we had printed here. So as a part of handling, exception handling, what we did is we just printed out saying that what kind of exception had occurred. So exception.get message that gave like divide by 0. This divide by 0 that you see here is nothing but is printed out by this message. So it gave you an opportunity to handle it and get the program running as is. So try catch finally block. Basically what I can do here is let me define integer denominator is equal to 0. So as I said, finally block is going to execute no matter what, is going to get executed. So I just print a message here saying, I'll say here, I'll put denominator. When the denominator is 0, we would get an exception and it would come to the exception block here or the catch block here and it would print it and then it would come to the finally block. So let me run this and see. So as you could see here, it came to the exception handler. It got arithmetic expression that is divide by 0 and then we printed out saying that printing the typical message or the actual exception that we got and it came to the finally block here. Let me put a scenario which is not going to throw exception. In this case, my denominator is 1, which means 29 by 1, which shouldn't throw any exception. So what I want to show is still it would execute the finally block. So you could see here 29 being printed out, which this got executed successfully this time because the denominator is not 0, it's 1. It got successfully executed. Still the finally block is being executed. Why to use multiple catch blocks? So you could have multiple exceptions and you could write multiple catch blocks. There are different exceptions that we spoke about. There could be like null pointer exception as well, which you want to handle, right? So it depends upon your program logic or what you're trying to do here. So there could be null pointer exception, then you have finally, so you have multiple catch blocks here. So you usually don't handle null pointer exception, but this is just to give you an example. So basically you have this arithmetic exception here being handled, then you have null pointer exception being handled here, then you have finally. So if you want to have different exceptions to be handled within your application, you could have multiple catch blocks. Since all the exceptions are derived from exception, catch exception E should be placed at the end. So basically, if you put the exception, there's exception, right? If you remember the hierarchy that we spoke about, all the exceptions are derived out of exception class. So you could have something of this sort. So if it is not an arithmetic expression, not a null pointer exception, then there's of course going to be some kind of exception which is going to be handled in this exception block. So basically we are catching all the exceptions here. First is specific to arithmetic exception. The second one is null pointer exception. If it's not a null pointer exception or arithmetic exception, then this particular catch block is bound to get executed. And it has to be last. You cannot place it first, because if you place it first, these two blocks, exception handler blocks, will never get executed, because even these two exceptions are a subtype of exception class itself. So it has to be, it is mandatory that you place it at the end, or else it would give you compile time exception. So you could have something like array index out of bounds and stuff. So just to give you, this is integer array. I put 1, 2, 3. I define an array. Now I say integer array of, there are 3 elements, right? And if I try to access or just choose. So when there are 3 elements, the index ranges from 0 to 2. So now I put 3 here. So this is generic exception handler. For all the exceptions, we would have this handler. When you run it, this is going to give you array index out of bound because you're trying to access element at index 3, which doesn't exist, right? So you would see a generic exception handler. So it came here. What I was trying to say is, so you could have array index out of bound here, right? So instead of null pointer exception, now I have array index out of bound. Now it would be handled by this block and it wouldn't come to the generic exception handler. So here you saw it came to the generic exception handler. Now what you would get is array index out of bound exception handler, because it's been handled by this particular catch block and not the last catch block. So this one is, as you go down, it becomes generic. So here you could see it's been handled by array index out of bound exception. So as you go down, it becomes generic, more generic. Why do you use multiple catch block? So this is pretty much similar. We have array, we have arithmetic exception that occurred. Array has 4 elements, 0 to 3, and you're trying to access the 10th element. That's when you would get array index out of bounds exceptions, as we saw. There could be a nested try, wherein you could have try and inside try. So basically, when you have try inside try, if there's an exception that occurs in the nested one or the innermost one, it would try to see if there's a catch handler for that particular exception innermost one. If it doesn't find, then it goes to the outer one. So in many cases, it may happen that a part of the block may cause an error and the entire block may cause another error. In such cases, we are going to nested try block. So what I was trying to say is you have this one, could have one more like exception E, or shouldn't be none. So you have a nested one. Within this try, you have one more one, this thing which says array index, which is handling null pointer exception. It's handling just the null pointer exception. It's not handling array index out of bound. So what I was trying to say is, if such scenario occurs, it would check the innermost one. If it finds the exception handler, it would execute it. If it doesn't find, then it would come to the outer one. So basically, though this try doesn't have handler for array index out of bound, still it would be taken care of. So you can see here, it came to the outer one. So if you would have some piece of code right after this, it won't get executed. So this piece of this code will not execute if inner try. So basically, if there's a exception which occurs in the inner block and if it's not handled, it would come to the outer block, but this piece of code, whatever you have in between this catch and this catch, wouldn't get executed. Why to use throw keyword? The Java throw keyword is used to explicitly to throw an exception while executing the program. So if you want to throw something, as I said, you could create your own custom exception, and if you want to throw something, you could throw it out. You could throw an exception from your program. It can be used to throw checked or unchecked exception. Any kind of exception could be thrown using throw. And the Java throw keyword is used inside a method. So you could see here, basically, if b is equal to 0, you throw new exception, divide by 0 causes an exception. So before it goes to actually dividing it by a by b, you are kind of handling it prior to that. You are checking whether denominator is 0. If the denominator is 0, you are throwing exception by yourself. You are creating a new exception. This is kind of your own exception, right? You're creating your own exception and saying that it's divided by 0. So for any condition, so basically if denominator is equal to 0, you could throw it from here, saying or denominator. So basically if I keep this denominator as 0, and this should be prior to this, just cut this and this should be done prior to this. Okay, when to use throws? Throws is something, as I said, when you have a checked exception, you can either handle it using try catch, or you have to throw it out of the method saying that I am not going to handle this. Let the caller handle it. You could do that using throws keyword. The method is not taking the responsibility to handle a checked exception, and it is, asking the caller of the method to actually handle it. This is in terms of just checked exception. when you have a checked exception. So basically, since you're throwing it from there, but since you have handler here, it's coming to this. So you have this denominator, you threw an exception from here, but this exception is been handled here. So it came here saying that generic exception handler. All right. So if I remove this, that's the reason you have generic exception handler here. So I remove this handler. I'm not going to handle exceptions. Whenever you throw an exception, it has to be handled since exception is a checked exception. So basically you could have runtime exception which need not be handled. So basically the handler that you see here, we just have two handlers, which is for arithmetic exception and array index out of bound exception, but we don't have handler for runtime exception. So that's the reason it gave you an error saying denominator is 0. So this is the exception that we threw here using throws. So it's giving you an error right here because this is a checked exception. The exception itself is a checked exception. Now you could either handle it like the way we had handled it here. You could write catch exception and you could handle the way you want to. So you have two options now. When you get into this scenario, into this situation, you have two ways to handle it. Either write exception and handle it. This would be a handler. If you see, the compilation error has gone. Or this is one thing that you could do. Or the other thing that you could do is you could ask this method. This method can say, I'm not going to handle it. I'm going to throw it for my caller to handle it. So the main method is saying, I'm not going to handle it. I'm just throwing it off from my side, from my code for the caller to handle it. So see, the exception has again, the error has gone. So basically, whenever there's a checked exception, you have two options, and this is happening at the compile time, by the way. So you have to ensure that you either handle it or you throw it. Throw in the sense throws. It's through throws. Main is saying that I'm not going to handle this. Let the caller handle it. As you could see, the throws keyword was added in the method signature. We saw how we throw exception. We throw exception from here. You check for some condition, you throw exception from here. Why we use throws? Throw is basically to throw an exception and a method saying that I'm not going to handle the exception. So what's the difference between throw and throws? The throw keyword is used to explicitly throw an exception. The throws keyword is used to declare an exception. The throw keyword is followed by an instance. The throws keyword is followed by throwable class. All right, so here you could see this is throws keyword is actually by instance. You create an instance of exception, whereas throws is the class itself. Throw keyword is used within a method and throws keyword is used with the method signature. So you could see throw is used within a method, within the method body, and you could see throws at the signature level. So you have throws and throw. So throw is nothing but whenever you want to check whether there's an exception and you want to throw it out, you want to actually trigger the exception. That's when you would write throw and you would throw this exception. So basically here we are checking for a condition if denominator is equal to 0, which is potentially which would cause error further down the line. So we are checking it upfront saying that if the denominator is 0, then we are not passing it further, right? In such scenarios, we could throw the exception right away. That's how you trigger the exception from the program. Throws is nothing but it's at the signature level of the method that you could see. And what you mention out by throws is that main is saying here that I'm not going to handle the exception. I'm just going to throw it off. So these are unchecked exceptions, by the way. So whatever is not being handled here, if there's some exception handled here, it would get to the exception handler or the catch block. But if there's something that is not been handled here, would be thrown out of this main method. Main method won't handle it. That's the reason why we have throws. Throw keyword is used within the method and throws keyword is used with the method signature. Throw keyword can throw only one exception, whereas throws keyword can be used to declare multiple exceptions. Basically, you could have something like there's one exception, say IO exception. So you could have multiple exceptions here. So the main is saying I'm not going to handle IO exception. I'm not going to handle exception or something of that. So you could have multiple exceptions after throws. User defined exceptions, you can create your own exception and it is called as user defined exception or custom exceptions. A user defined exception class can be created by creating a class, child class of exception. So basically create an exception I create a class which is, say, custom exception. Now this custom exception is extending exception. So you could have your own classes defined and it would have like this. So whatever exception you get, you could pass that exception directly here. So this is basically what I'm trying to do here is overloading of constructor. So you could see if you're passing string, it would come to this. If you're passing exception, it would come to this constructor. So you could create your own exception here. So basically to give you an example of this, instead of exception, what I throw is I can have a new custom exception. So initially I was throwing exception. Now what I'm saying is new custom exception. This is the exception that I have created. It's my own exception. When I run this, now you can see that it should throw custom exception. So you can see here exception in thread main. Thread main is nothing but your main method where your program is executing, and it shows the exception type, which is custom exception, which is created by me. And I have passed the string saying that denominator is 0 and at what point or at which line this particular exception occurred. You can see it in the stack trace. This is a stack trace. Basically, whatever you get here when an exception occurs is nothing but stack trace. So hi everyone, welcome to module number 4. Before I start off, I'll just brief on what we covered in module number 3. So we covered on OOPS concepts. In general, what are the OOPS concepts? What are different concepts or terminologies that we have in OOPS? Then we saw how Java is aligned to those OOPS concepts, how Java is known as object-oriented program, right? Or how Java is aligned to object-oriented programming paradigm. Then we spoke about abstract classes, which is a different modifier altogether, right? And then we spoke about 100% abstraction, which is nothing but interface, which is a construct in Java, which helps you to specify something, and you could have different implementations as per the specifications. Then we spoke about exception, right? What are different exceptions and why do we have exceptions at all? And how do we catch exceptions, or what is the need to catch exception? And what are different types of exceptions, right? You have like checked, unchecked exceptions. Checked exception has to be caught by your application, or a particular method might opt to just throw it off rather than actually handling it through the throws keyword, right? We touch base on regular expression as well, and why do we need regular expression, and what are different classes that Java has to support regular expression. All right, so today we would be covering file handling and Java collection framework. All right, so file handling is nothing but you have external files. You might have something on your network, or it could be on your local machine itself, and you want to access it and do something on it, or you might want to have data that's been coming to your program. You might want to write it into a file so that you could kind of analyze it later. I spoke about exception, right? If you get an exception, you could write it into a file so that you could later on go through it and understand at what time a particular exception occurred and you could act upon it. So it's a kind of profiling and instrumentation done on application to understand more on the behavior of the application and to improvise on it. Such activities could be done using file handling. We'll talk about Java collection framework. Java collection framework is nothing but you have array list and everything. That is, we spoke about arrays in the previous topics, but Java collection framework itself exposes array list, which is a dynamic list. You don't have to manage it. So remember, in list we said that when you declare a list or declare an array, you have to mention the size of it, whereas array list is dynamic. You don't have to mention it. It keeps growing. So these are the topics that we are going to cover: file input output of operation in Java, wrapper classes in Java. We are going to talk about Java collection frameworks. We are going to talk about list and its classification in Java, queue in Java, and sets and their classification in Java. So as you could relate, all this collection, all these components within the collection frameworks are nothing but data structures in general that's used, right? So maybe in C, you might have used different data structure, and whereas in different languages, you have different data structures, right? This is just to handle data. Data structures are nothing but to store data efficiently, and you could select one of them based on the use cases that you are handling within your application. So let's start with file IO. File IO is nothing but you have a file on your disk, and if you want to do something, if you want to write to that, or if you want to read from that file, you would ideally use file IO API. All right. So file IO is used to process the input and produce output for a specific file. All right. So you could access some file within your local disk, do something, and you can write it onto a different file as well. All right. Java.io package contains all the classes required for input and output operation for a file. All right. So as we said, package is nothing but namespacing, right? So everything is grouped, all the IO classes or all the classes in Java that is handling IO is grouped into java.io package. Okay. That makes it easier for programmers to understand as well, right? So if you're doing a lot of IO operations, you could directly say import java.io.star, which would import all the classes within your java.io package. All right. The files can be text file or it could be binary file, right? So you could imagine not always you deal with a text file, right? You have other files as well. So nowadays there's a lot of things going on IoT, right? Internet of things. So you get data from different systems. It could be like your mobile phones, it could be from the car sensors or elsewhere, right? You have a real time raw information coming in into your system for analytics. So such data cannot be a text file because text file as such is a heavy file, right? So such IoT applications, what is being passed between systems or intercommunication between systems is done through a binary file, which is kind of lightweight, right? Compared to text file. Text files are heavier. So you could imagine this files not being just the text files, it could be binary files and so on. When I say binary files, it could be images as well, right? Different images that could be shared among system or some image that is there on your local disk which you want to read into Java and do something on it, some kind of graphical processing on it, right? Stream is a sequence of data, so you convert this file into a stream and you use it within Java. Okay, we'll look at example which would give you a clear idea of what I'm talking about. Okay, so here you can see an example wherein you have a file which is student.txt into your local system, into your local disk where you are running this program. All right. Then you have a print writer. This is nothing but a print writer is a class that is exposed by Java, which is there in java.io package. You would pass on this file. So initially you have new file and you pass on the path of this file that you are going to read or do operations on. Not just read, it could be write operations as well. So basically you have new file and you specify the path name or initialize the file. The next thing that you do is you have print writer wherein you pass this file. All right. Now what we are trying to do here is we are trying to write into a file. All right. We are trying to write the name or there's some ID or something. We are trying to write this content into a file, right? Into your local file. We'll write a program on this which would give you a clear idea. And the next step that we are doing here is kind of we are reading it from a file. All right. So the first step that you do is write into a file. The next step that you do is read from the same file and print the contents of it. All right. So it's not mandatory that you have to specify the same file for reading, right? This is for just for the convenience or just to demo it. We are using the same file. You could have different file as well. All right. So let me show you how this is done. So again, I create a new project for today, which is, all right. So we create a new project, it's Edureka module 4. All right. So we have this project. Now let's create a new class. com.edureka is nothing but the package name. And I give, say, input output demo. All right. So before we start off, I can do one thing. I can create a folder here. It says Edureka IO. All right. So we'll put all the files here. So this is an empty folder that I have created right now, or let me put it here. So for simplicity, I'm going to put it on C drive itself. All right. So on C, I've created Edureka IO directory, wherein we are going to dump all the files, right? Whatever we are going to do, it's going to come into this particular directory. All right. So the first thing that we are going to do is, so now we are thinking of writing into a file first, right? So I create a main method. right? The first thing that I do is create a file. All right, and I create a new file, which is nothing but I'm calling the constructor of a class of the class file, which is within Java, right? It's not something that we are writing. So Java itself has this internal file class, which is file. All right, so now I point to this particular directory. All right, com.edureka.io, and we say, so I call it as employee-info.txt. All right, so we are going to write into this file now from Java program. So now it's showing up an error saying that which file I want to refer to. As we said, all the IO related files, all the IO related classes are placed in java.io package. So I select this package. Once selected, you can see an import statement here coming up. So why do we have import statement? Because file is a class which resides in a different package than com.edureka. Had it been within com.edureka, you need not import it. It's outside, so you have to import it. All right. Then there are different ways in which you could write it, but now we'll follow the same example. So I write print writer. Print writer is there within java.io, and you could see it imported here. All right. Employee info writer, say for example. Okay. Now create a new print writer. And if you see the constructor of print writer, so we spoke about constructor overloading and stuff like that, right? So you could see, if you go into the source code, if you want to deep dive more, you could go into the source code and see it takes file. All right. So here you could see an option, which is nothing but it consumes file. So the file which we created above, I can put it as employee info file. All right, so there's a file that's created here. So I put the same file here. All right, since the constructor supports file itself. Now this is checked exception. All right, you could see here it is saying Java is explicitly saying that you are not handling this exception. All right, so ideally the better practice is you shouldn't be writing everything into the main because it would become cumbersome to understand later on, right? You shouldn't be dumping everything to the main method. So as a good practice, what you should do is you should create a new method, write to file. All right. So this is best practices, right? It's not mandatory. Java is not going to tell you there's an error or something, but as a part of best practices, this is how you should write programs, which would make it readable for others, because tomorrow some other developer is going to handle this particular class. It's not that you are going to be there throughout, right? So basically, so that other developers can easily read it and maintain it well, this is how we write it. I move this content. So whatever the writing part is, I move this content here. All right. So now it's showing up an error saying that it's not been handled, right? File not found exception is not been handled because it's a checked exception. So remember, in the checked exception, we said that there are two options. One is to handle it within your method, or this write to file method can opt to throw it off, saying that I'm not going to handle it, let the caller handle it. So when I say caller is nothing but this method. All right. So I'm going to create, say here, input demo. So I'm creating an instance here. All right. And demo write to file. And I'm going to pass the file that we created here. All right. So there was one file that we created here, which is pointing to an employee info.txt. And we are calling this method to write it. If you think about the reusability part of it, so this is how you make the method reusable. If you put it into main, you cannot reuse it. If you're taking the right logic outside the main and refactoring and putting all the code that is specific to writing to a file into a particular method, you could reuse this method. You're making it generic, right? Now I opt to throw it off, or let's handle it. All right. When I say let's handle it, it's nothing but you have try catch block. All right. So I say catch. So what exception was that? It was file not found exception. So you need to have file already in place. All right. So here I print saying that given file was not found on the local disk. All right. And what's that file? Maybe we can print the name of the file as well. All right, so here we have chosen to handle it. Okay, so we remove this. All right, so we have a try catch block written now, and we say that, okay, so we are handling this error. So we say that just print a message saying that given file was not found on the local disk. And as a good practice, I don't want further processing, right? If I don't have a file, I don't want to process it further. So I say throw runtime exception, and so runtime exception is unchecked exception. It won't give you error even if you don't handle it, right? Whereas this was a checked exception, that's why you were getting error. Basically what I'm doing is I'm catching the checked exception and wrapping it into unchecked exception. All right, because I don't want this to be processed further. So once we have this print writer set, so I'll have to take this print writer outside, or I'll put it here. All right, so what I do is employee.println, and I write some content to it, and say in this case I'm writing Vinod. I write some ID to it as well. Anything you could write, okay? Once I write into the file, I have to ensure that I close the file. So basically you could have finally block. So you would do, for this I'll have to take, so this, if this is within try, so it's not accessible within the finally block. So to make it accessible, what you will have to do is you'll have to take it outside. All right, so I define it outside try block so that it gets accessed in finally. All right, so now what I do is employee info.writer.close. I close it. So that's one of the use cases of finally, as I said, it's basically for closing the resources. So this finally would execute even if this doesn't throw or don't throw any exception, and it would get executed even if it throws an exception. All right. So that's what the use of finally block is. So let me quickly run this program to see. So I have to create a file here. So I create a text file here, .txt. All right, before I create a file, maybe I would want to show you what happens if we don't have a file, right? So if you don't have a file, I run it. So we don't have anything into C Edureka IO. All right. Basically, you're trying to write into a file which doesn't exist at all. So it's building and it's running now. Even if you don't have a file, it doesn't throw file not found exception. Rather, it creates one on its own. So remember, we didn't have anything here. Now let's see the content of this file. You could see whatever we wrote, right? The employee name, and you could see the employee ID, which is 100. So whatever you wrote here came into that file. All right, now let's write a program to scan or to read through this file. All right, so maybe I can use the same file or I can use something like, all right, so I write something like BMW, Mercedes, Audi. All right, I write something like this, say it's a vehicle info, and say you have something like, or let's keep it as is. Okay, so you have vehicle info in here. So now we are writing a program to read from a file. All right, so we pass on the file parameter here. There are different ways in which you can do. All right, so we create scanner. Now scanner takes, if you see constructor, you could see that scanner takes file as a parameter. All right, so I put scanner file. Again, it's saying that file not found exception is to be handled. So in this case, you have to be sure the file is present, right? Since you are reading the file, in the earlier case, it was writing to the file, which can create a file. But reading to the file, you have to be sure that the file is present, or else you would get a file not found exception. So in this case, I choose to throw the exception. The read file is saying that I don't want to handle this exception. I instead throw it off. All right. You could see throws here. Okay. Now what we do is we read lines from it. All right. So we have like, Okay, so we read line from it and we just print it out. Basically, you would have something like, so let me just print line read from the input file. All right, so this is nothing but we are just printing whatever we read from there. And basically, this should have something like it should loop in until it's the end of the file. All right, so this is how you use the while loop, similar to what you do in C and C++, right? Till the end of the file, till EOF character is encountered, you kind of read the lines within the file. All right, so this is a method that we have written, but we haven't invoked this method yet. So I create file. Since it's a different file, we have to create a file. Vehicle info is equal to new file. We give the path of it, which is nothing but edureka io vehicle info.txt. All right, we created a file here. Now what we are going to do is we are going to call read file on this file or vehicle info file, and we should be able to see the contents of it. All right, so now one thing here is since you have thrown exception, it's saying that exception has to be handled here. All right, I can choose to not handle the exception here as well, and I am adding it to the method signature. So main would throw as well. So basically what would happen is if you don't have a file which is being read, your program would stop at that point because you're not handling it anywhere, right? You're just throwing it off up the ladder. So basically at the end, if you don't have a file, you're going to get a exception. Your program is going to stop there. I run this file and let's see what we get. All right, so you could see BMW, Mercedes, and Audi being read out from vehicle info. This was the content that we had within the file and which you could see it's been read. So file writer and file reader. So similar to print, this one is a different way of writing it. So what's written within this program is nothing but we create an instance of file writer and we pass the string, the path of the file rather, as an input to the file writer. Now file writer is nothing but it's character oriented, right? Print was not as such character oriented. This one is character oriented, which means 2 bytes, right? Character is nothing but 2 byte size within Java. So this one is not like it doesn't work at the byte level. Basically, whenever you're dealing with character oriented file, you could use this one rather than print writer. All right. Object of file writer is being created, which is a character oriented file or which is a character oriented class. All right. And you write to a file. You're writing to the file here. All right. And similarly, when you use file reader, it's a character oriented reader. Reads character, one character at a time from the file that you have mentioned here. So maybe I'll take just an example of writing it because it's going to be pretty much similar. So I'll quickly write this program. You have a main method. You create a method to say you have public or it could be a private method. As I said, the best practice would be to restrict as much as possible, right? If you don't want this method to be called from outside, you could have private method. So it's going to be write to file. So you need to give string or you can have file as well, whatever you prefer to. You would have file and file to write to. Okay. So basically we were talking about file writer, right? So I create file writer object. Okay. And again, say it's a bike info. And I pass this file to which you have to write. All right. So again, you could see now you could see a checked exception that is nothing but it is showing that IO exception has to be handled. Now I choose to throw it off. I'm not handling it here. Bike info dot I write to the file and I write some content. Basically, this should be writer just to make it more elaborate. All right, I say writer dot close this particular file. Okay, now I give a call to this method, which is nothing but file writer demo is equal to new. We are creating instance of it. Okay, let me create a file, which is nothing but file bike info file. and which is new file, and within the same directory, which is nothing but com.edureka.io, I create bikeinfo.txt. All right, so what we are doing here is using file writer, we are going to write into bikeinfo.txt and we are going to write this content, that is Ducati. And maybe after this, we could have, so whatever you have in buffer, that would be flushed off to your disk. All right, so when I run this, basically we don't have a file now, bike info, and I think it should create it. So you could see here, we don't have a bike info file. Okay, so again, let me talk about this program. So what we have written is we have a file. So what we are trying to do is we are earlier in the program, we wrote using print writer. Now we are going to use file writer, which is a character stream based IO. So we are going to write into bikeinfo.txt file, and we have a method write to file in which we are creating a file writer object, which is taking up this parameter or taking this file, which we are going to read through as an input. All right. And not read through, it's rather write to. So the file to which we are going to write is taken as an input parameter to the file writer, and we are writing into this file. So right now we are just writing Ducati there. All right. So I invoke this method like file writer demo dot write to file, and I pass on this file here. All right. Shows up an error that you have to handle IO exception, which has been thrown from write to file. So I choose not to handle it here as well, which means if you don't have that file, or if there's some IO exceptions that's been triggered, program would stop. All right. So I run this program. So basically it should create file and should write to it as well. All right. So I go to the directory. So you see bike info file has been created here. We didn't have it earlier. It got created after we ran this program. Now I just open it up and you should see the value Ducati being written there. All right, so that's about file writer, and similar to that, you have to just read through it. You have to pass the file that you want to read as a parameter, and you just have while loop to iterate through till the end of the file, and you can print the character. So basically, it's pretty much similar to what we did for the print writer, but I just wanted to demo for one of these cases. So we took an example of file writer. All right. So now let's move towards stream-based IO. So Java streams are used to perform input and output operations on 8 bits, a byte, right? Streams is basically operating on a byte. Input stream, it is used to read the data from the source. It could be file, it could be keyboard, or it could be anywhere across the network, right? It could be a socket as well. So basically, it is used to read the data from the source. That's input stream. And output stream is nothing but if you want to write something from your program to any resource on a network, that would be nothing but write. That would be nothing but output stream. All right. So with output stream, you would typically write data to a destination, and with input stream, you're going to read it from a source. All right, just to walk you through. So we have object, as I said, all classes or every class in Java is inherited from a class that is object. All right, this is a super class for all the objects, all the classes in Java. Okay, so you have object and you could see that there's input stream and output stream. So let's talk about the input stream. There's file input stream, there's byte array input stream, there's filter input stream, and there's object input stream. So we'll talk about this in the coming slides. Why do we have object input stream and stuff like that? But right now you could imagine that we have multiple classes, or you could think that there are multiple classes with it input stream, which are used for different use cases. Like you have buffered input stream, which is nothing but it buffers it. It doesn't read or write it in one go. It sort of buffers it and then it flushes it over. All right, output stream, similar to input stream, we have a output stream. It's an interface, I believe, which has got several implementations like file output stream. You have byte array output stream. You have filter output stream. You have object output stream. And filter output stream is further categorized as or has further subclasses as buffered output stream and data output stream. All right, so in further slides, we are going to discuss file input stream, file output stream, object input stream, and object output stream. Okay, so file output stream class and file input stream class, let's talk about it. So file output stream class is used to write to a file, right? You could take a byte array and you could write to a file. All right, so you could take something, if you have a string, you could convert it into a byte array and you could pass it and it would write to a file. So remember we said it's a byte oriented, right? So basically it's going to take array as input and it's going to write to the file that you have mentioned in there. All right, so you could take integer as well. It is used to write the specified byte to the file output stream. So you could provide integer as well. There's a close method, which is nothing but closing the stream. So streams are nothing but it is hooked up to the resources. It is taking up resources and there's a connection between your program and the file established, right? When you create streams. So when you close it, you close that connection and it is free for garbage collector to remove that particular object from memory. So basically it frees memory as well, right? Unless you close it, it's going to stay in the memory. So it's a good practice to close it right after you use it. Okay. Writes, you could write to a particular offset, which could be done using write method. So write length bytes, whatever length you have mentioned in as third argument, it would write it to a particular offset. It would write the byte that you have given or byte that you have passed in as input. It would write that byte into a particular offset. You have flush method, which is nothing but flushes the output stream and forces any buffered output bytes to be written out. All right. So it could be buffered, as I said. So not writing it each and every time you have byte. Basically, it buffers it, and you could have flush method to flush it off to the file. So basically, we have buffered stream, which uses this method. All right, so here we have file output stream, and using file output stream, we write it to the file and then we close the file. All right, as far as the syntax is concerned, it's pretty much similar to file writer example that we took, but just to give you a demo, just to show you how it is, we'll have one demo done here. All right, so I create a new class, which is nothing but file output stream demo. All right, so we have a main method and I create a new method which is like file write to a file, which could be like private method, private void write to a file. All right, so we are going to write to this file using what? Using file output stream. So it's showing up this. So I select java.io.file. All right. Okay, now I create file output stream. I create instance of it, right? Similar to how we did for other programs. Now it says file not found exception has to be handled. I choose not to handle it and I throw it back to the calling program. All right. So now what I do is I do file dot write file output stream. I am going to write it to this file. So I just write a text here. All right. So write a text here. Hello folks, hope you are enjoying the session. And I just close it off. Again, it throws IO exception when you close it. So remember we said there could be multiple exceptions that could be thrown out of a method. So I choose to throw this one as well. So basically what I'm trying to do here is I throw IO exception as well. Okay, so it doesn't take a string as an input. So what I have to do is I have to do dot get bytes. As we saw the constructor of it, constructor doesn't take string as input in case of output stream or in case of file output stream. It interacts in terms of byte array and stuff like that. So I converted this string into byte array. So when you see get bytes method is a method on your string class which converts the string into array of bytes. All right, so now what I do is I give a call to this particular. I'm writing to a file and I'm going to create a new file. So I can take the same file, right? I'm going to take maybe, or else I'll create a new one. All right, so I create a file which is like message.txt, or you need not even create it. It will create by its own. I'll delete it maybe. Okay. Only thing is I'll have to create C edureka.io. All right, and here we say message.txt. All right, so I call a method to write to the file using file output stream. I choose to throw it off from here as well. All right, so we have a method which is going to write into a file using file output stream. All right, so I run this program. Okay, it ran successfully. Let me open this message and see if we have the message written there. All right, so you could see here, hello folks, hope you're enjoying the session, which is written from your program. All right, so there's file input stream as well, which is pretty much similar. It again operates in terms of bytes. As you could see the signatures of the methods within, it would read the contents of the file into the byte array that you have passed as a parameter. The second one is to read from a particular offset till the length that you have mentioned or passed as a parameter. Close is pretty much similar. It would close the connection that's been established and it would make the class available for garbage collector to clean it off. Okay. Garbage collector is nothing but unlike C, wherein you have to deallocate the memory location that's been used. Garbage collector is parallel thread that is run by JVM to remove the or to free up the memory space that's been acquired by classes. So it runs sporadically, it's not within your control. It runs sporadically and it clears off the memory locations. We have a read method, which is nothing but reads the next byte from the input source. So on the file input stream instance on which you read it, it would read out the next byte. And if it's end of the stream, it would return -1. So the return value is integer, as you could see here. You could skip specified number of bytes from the input stream, and available returns the number of bytes that can be read from the current stream, right? So maximum number of bytes that could be read out. So I'm just going to read through this slide, or if you want, yeah, I can take an example maybe. Since we didn't take example on reader, I'll take one example on reader as well. Okay, so here I do file input stream demo. All right, so we create a class here and I have a main method here. Okay, I have a private method which says void and it's not returning anything. And I say read from file. All right, which takes file. Again, I'll have to import file. Okay, so java dot, you could see the import statement coming up here. So now I create file input stream. Okay, I create a new instance of it, which would typically take, for that matter, it would take string as well. Just to show you a different variant of it. It's not that you have to always pass file, you could pass string as well. All right, so we are passing a string here. It says file not found exception has to be handled. Since it's read, you have to ensure that you have the file there, right? So I choose to again throw off this exception. So I'm not handling it. So typically you would handle exception when you want to do something on it, right? When file not found, if you're trying to read a file and that file doesn't exist in your drive, I wouldn't handle it. I would just throw it off. I want program to break right there, right? I don't want it to proceed because our program, this particular method is trying to read from a file. And if it doesn't exist, it doesn't make sense to proceed further. All right, so I have input stream. Now what I do is dot read, and as you could see, it's returning integer, right? So this has to be looped. All All right, this has to be looped until you get -1, right? So basically you would have like say integer, and you have like, so this is integer read from file. All right, and I keep this as integer, which is, so whatever you read, I need to assign this because I want to write that as well. All right, so I'm assigning to this, and unless this is -1, you are going to read through. All right, it again shows exception which I need to handle. So this time it's IO exception, and I'm going to throw this one as well. All right, so you have a read method, you are going to read it, and basically till the time it's -1, it's going to be read. All right, now what I'm going to do is within the loop, I'm going to just type. So basically I'm going to just typecast this to character. It's read as integer, so you have to convert it into character if you want to see in terms of character, or else you would get the ASCII value of it. All right, so once this is done, basically I need to close off the stream as well. Okay, now what I do is I create the instance of file put stream demo, which is nothing but creating instance of it, right? Demo.read from file, but remember this time we are not creating a file instance. We are just passing the string, all right? So you could take any of this file. Since we are reading it, we could take like, let me take bike info, right? It just got valued Ducati. So I'm passing this as a string this time, all right? And it's a different variant. You could pass it as a file as well. You could pass it as a string as well. But since I've been passing as a file in previous examples, this time I chose to pass it as a string. All right, so now I'm throwing it off from here as well, since I don't want to handle it. All right, so if I get an error, I want the program to break. So that's the reason I'm throwing it off from here as well. So I got an error. Let's see what's it. Okay, so I have to put double slash here. All right, I missed that one. So basically, if you don't put double slash, it would take it as a regular expression sort of. Again, it's not bike info, it's .txt, which I missed, I believe. So it says that bike info file doesn't exist, right? Since it's a text file, right? You have to provide the extension as well. All right, so you could see it read in terms of characters, right? So you could see the first character read as D, then you could see it followed till it read Ducati. All right, so that's about file stream or file input stream. That's how you write programs. Now, what serialization and deserialization? I'll quickly cover on this one. Since this is something that's been used widely in big data, when it comes to big data or when it comes to distributed computing, just not to, if you understand, it's good. If you don't understand, you don't have to think much, but I'm just talking in terms of distributed computing, right? So when it comes to big data, it's not that you have server farms and everything. Your program doesn't run on server farm anymore. It's more about you have commodity hardware on which a program is run. And that's what big data frameworks are good about. The investments in terms of infrastructure by having server farms has been reduced a lot, has been cut down a lot, and you could have commodity hardware on which you could have this distributed frameworks running. So say for example, you might have heard about Hadoop or Apache Spark, which could actually run on normal hardware, right? Or you could run it on cloud as well. So you have like Amazon Web Service, which is cloud, like you have Google as well, Google services, which exposes as a cloud. You have Azure, which is nothing but Microsoft's cloud. So all these are kind of not big hardware, not server farms that you have. It's a normal hardware that you could configure, and you could run through your chunks of data or petabytes of data that comes in from cloud or from elsewhere, right? So that's the beauty of it. That's the beauty of Java. And one of the main things or main feature that Java has got is serialization and deserialization, which helps in having this distributed framework going. Okay, so serialization is nothing but you have class, right? And you create instance of a class, which is nothing but an object, right? Now, this instance of a class, if you want to pass it over to some other computer or some other computer on your network, right? This could be done just because there's a serialization. There's a concept of serialization, right? Suppose I create some object of a class today on my computer, and if I want to pass the same state, right? It's about passing the state, not the behavior. Behavior is, of course, just methods, right? So it's about passing the state of the object. So whatever state my object is, or whatever properties my object holds at some particular point, if I want to pass it over to some other computer on the network, this could be done just because you have serialization. Because what you would do is, basically, if you remember, the object stays in heap, right? Heap memory, which is protected, which no other process can get into that particular heap process, heap memory, right? That's a security that Java provides. If you remember, in the first slide we covered it, right? So what Java does by serialization is, whatever contents of a particular object, or whatever contents a particular object holds at any, could be written into your disk as a binary file, and you could send it over to some other computer via wire, or you could take it, plug in your USB drive, and you could just take that particular file, the binary file that's created, and you can go elsewhere and just play that file, or just deserialize it to see the contents of it, right? So you could imagine this is something that is needed in terms of distributed computing. Since not everything is being carried out on a single computer, you would process something on your computer, you would write it to a file, and you need to pass on this file to a, or transport this file to a different computer, right? Or a typical example in which you would think of serialization is more about, you could have, say for example, one operation carried out on one computer, and same operation or different operation on a same file carried out on some other computer. Now you want to merge them together, and that's where you would have serialization and deserialization coming into picture. Basically, to understand the concept, serialization is nothing but writing the state of the object to a file, and deserialization is nothing but again taking the state of the object that's been written to the file, again putting it back to a class format. Or when you want to use this serialized class, you would basically deserialize it to use it. So serialization is a process of converting an object into sequence of bytes, which can be persisted to a disk or file, and can be sent through streams, or can sent across wire, or could be, you could actually take it on your drive and transport it elsewhere. The reverse process, which will convert data bytes into object, is called deserialization. All right. So how do we have this serialization and deserialization done, or what classes we have for supporting it? Let's talk about that. All right. In this example, you have a student info, which is having ID and name, right? And basically you could see that we have created an instance of student info, which has value of 9 and John. All right. And now what we are doing is we are writing the state. State is nothing but the value that this particular object holds, right? Which is nothing but ID of 9 and name value of John, right? So we are writing this into a file, which is nothing but student.txt, and we are just writing that to a particular file. Okay, and this is nothing but the student.txt file that you see. It shouldn't be txt actually. It's a binary file, so I would rather prefer to have student.bin or binary, and you would write it to that file using write object. So the supporting class for serialization is object output stream and object input stream. All right, so I'll quickly take a demo of this. So the first thing that we do is serialization. Serialization is done by object output stream. All right, so again, we have a main method. Suppose I want to serialize it, so I would do something like, say I have a private method which is void, which is serialize. Okay, so the first thing I would want to create is nothing but Java class which will hold the state, right? So this is a class which you want to serialize, or which you want to send it across to different computers. So such classes are known as model classes, right? Basically, such classes are nothing but classes which holds chunks of data. So for simplicity, we have taken small data, like ID and name, but in general, you would have like chunks of data there. All right. So here I say vehicle info. Maybe this is the class that I have here. All right. And now what I do is uh, suppose I have two parameters here. All right. So I have two parameters here, which is nothing but integer. And suppose I have like a string name of vehicle. All right. So now I define a constructor for vehicle info, which takes three parameters for simplicity. Number of wheels. First is, say for example, I take name of vehicle, then it's number of wheels, and say I have one more parameter, which is mileage. All right. Now remember, we use of this keyword since the name of the arguments and the name of the instance variables are the same. We need to use this dot number of wheels is equal to number of wheels. All right, and this dot mileage is equal to mileage. All right, so this is a simple model class which is supposed to hold values. Basically, in reality, this would be holding like chunks of values. Okay, imagine like could be like megabytes of information or even huge gigabytes of information. All right, but for simplicity here, we are taking this simple class. All right, now what we want to do is we want to serialize this into a file. We are going to create an instance of this particular class, and we are going to write the state or whatever values we have in that particular instance. We are going to write it to a file so that it could be read from somewhere else, or it could be used by any computers on the network. All right, so I have vehicle info. Again, suppose I write BMW is equal to new vehicle info. Now what I have to pass is name of the vehicle, which is BMW. All right, number of, and I pass some value like 10. All right. Okay, now we have created instance of vehicle info and we have passed the values that we want to pass it. And now we want to serialize this. Okay. So how do we serialize? Is nothing but we use object output stream, right? So what does it take? So basically you could go into the source code, and if you want to deal more, you could actually see what are the constructors that it takes. You could see it takes output stream. So one is output stream as a constructor. If it takes output stream, then I'll have to create file output stream. Basically, I'll name this as object stream, and this one would be file stream. Okay, I create a new file output stream, and you could pass the file on which you want to write it. All right, so in this case, the file on which I want to write a particular class, I'll pass it as file, and I'll be passing it over here. All right, so what I'm trying to do here is resolve this. Okay, so you take the file to which you want to serialize. So basically this vehicle info would be serialized into this file, and this file would be transported anywhere across your network. So it shows file not found exception. Again, I choose to throw it. It shows IO exception. Now I've passed this file stream here. All right, so this is how we usually write programs. You have file input stream, a file output stream, which is nothing but the file to which you want to write the state of the object, and you instantiate object output stream. Okay, now let me write to it. Okay, so basically what are you going to write is nothing but vehicle info, just instance of. Okay, so you want to write this instance of vehicle info, particular instance of vehicle info into the file. Okay, so I write something like this. Okay, so basically what we'll have to do here is whenever you have this thing, whenever you want to write or whenever you want to write the state of a class to a file, you need to implement one interface which is serializable. All right. It's a do nothing interface. It's just used by, it's a markup interface as well, marker interface rather. It is just used by JVM to say that this particular class could be serialized, but it doesn't have any methods within it. As you could see, if it would have had some methods, it would have shown an error saying that you should implement it. But in this case, it didn't because it doesn't have any methods within. All right. So basically, when you have object stream dot write, okay, so it takes, all right. So
So,
we create an object stream, and we pass the file that we want to write to, and we have write object method which would take the instance of the class that you want to write, and we have, like, we flush it and we close it. So one thing to note here is vehicle info class has to implement serializable. That's a marker interface. Serializable is nothing but a marker interface, and it doesn't have any method within. It is just an indicator. As you could see, it's an empty interface. All right. This is the source code of it. You could see it's an empty interface. It is just a marker, or it is just a notification to the JVM saying that this class is something that could be serialized. All right. So we have this class and we are going to serialize the state of BMW object into a file. All right. So now what I do is I create object output stream demo and I call serialize within it. Now this serialize is taking two parameters. So if the first parameter is, this is other way of passing it. We are not actually creating instance. We are passing it directly. All right, so I pass this and I say serialized file, okay, or maybe dot bin. And the other parameter that it's taking is nothing but the instance of class that you want to serialize. All right, so here we are again getting exception which needs to be thrown off. All right, so this is a simple class that we have. We have vehicle info, which carries BMW instance, or we have created instance of vehicle info with BMW values, and we are trying to serialize this to a file, which is serialized file.bin. Okay, let me see if it runs. All right, so I hope it ran. Now this is a binary file. If you see, you're not going to understand everything that you have within this file. Okay, so I just, okay, so here you could see it's not something that could be completely readable, but you could get some idea about it. It's storing BMW. All right, and this is not meant for you to read it, right? It's not in a human readable form. This is basically for passing this over a network, and at the other end, you would deserialize it. All right, so this is how we serialized it. Now we will check on how we deserialize it. All right, so you saw the contents, right? It's something that is not readable. Okay, again I'll open it up. Not everything would make sense, but you could see that this is for BMW. So basically you could see the value BMW here, right? So now what I do is I want to deserialize this, right? So this is how you serialize it. We spoke about it, how we serialized it. Now we are going to deserialize this. So basically this deserialization won't happen on the same computer. It might or might not, or it could be say different application within the same computer as well. So if you have two applications running and if you want to interact between the two applications running on the same computer, could use serialization and deserialization. Or you could, majority of the use case for this feature is more about passing it over the network. All right, so let's see how we deserialize it. Okay, so when you deserialize it, you use object input stream. Okay, so in the same class, or I'll just for simplicity's sake, I'll change this to object stream demo because this is not just, all right. So I refactor it and I rename this to, okay, so this has been renamed to object stream demo. Now create a private method, which is nothing but void deserialize. Again, for deserialization, you need to have the file, right? You could imagine of you having the file and file should be okay. Okay, so now what we do is, so basically we could have this as a file rather, since we are going to send the same file for deserializing as well. So it's better to have it defined here and you pass it as serialized. Okay, so far we have serialized it. Now we are going to deserialize it. So what you do in deserialization is nothing but you use object. So the first thing that you will have to create, similar to we created file input stream above. Now we are going to file output stream in the serialized case. But here we are going to create file input stream. And I provide the file here. All right. So we have file input stream created. Now we have object input stream. All right. We are creating instance of it and it would be new object input stream and you would be passing the file input stream that you created in the step above. All right. It's showing you for exception. You have to could either throw it or you could handle it. So in this case, I'm throwing it off. All right, so we have, so here you could see we had write object. Now I'll have read object. So read object throws file not found exception or class not found exception that you need to handle. All right, again throw it. So here you could see IO exception and class not found exception, right? Single method can choose to throw multiple exceptions from within. All right, so we have chosen to throw it. Now we have vehicle info, or we don't know whether it's BMW at that point. So I say deserialized object. All right. So object stream dot read object by default it returns object type. So we need to typecast it. This is how we typecast it, one form to other. So basically we know that object stream dot read object is going to give us vehicle info object. That's why we can actually typecast it. All right, so now what I do is once I get this deserialized object, I'm going to print out the values that I have within. All right, so I'm going to print the name of the vehicle. So I say, all right, put as, all right, so name of the vehicle in the serialized file. Similarly, I just copy paste it. We'll print number of wheels. All right, and we'll print mileage of vehicle. Don't need this one. All right, so basically we are serializing it and then deserializing it. After deserializing it, we are printing the value of the contents, or we are printing the contents of a particular object to see if it is what we expect. All right, so maybe I can do one thing. I can delete this off. Let me close this and let me delete this off. Okay, I'm deleting serialized info. I'm going to run this program again, and this program will serialize and deserialize it. Okay, it will serialize it in the first case, and now I'm going to write for deserialization. Deserialized and the serialized file. All right, now here as well, I'm going to throw it. Okay, so first we are going to serialize it and then we are going to deserialize it and see whether we get the contents that we expect. All right, so it's running. Let's see if the file has been created. So we deleted the file. It's not yet come. So we can see that a file was created here, right? Which is a serialized file. And we printed the value from deserialized file as well. After deserialization, we printed the value of the contents in the serialized file, which is like we got the expected value, which was BMW 4 and 10, which you had said. So basically what we are doing here is we are storing the state of a class or state of the object to a disk, and this could be transported anywhere. When I say it could be transported, it's nothing but this is just a binary file, right? So you could take it into your text file or you could take it into your pen drive and you could take it anywhere. All right, so that's the beauty of serialization and deserialization. I spent more time on this because this is something that is very important for big data. Since big data is nothing but all the big data frameworks that we have, They follow distributed computing, and this is one of the important internals of distributed computing. Though you need not take care of it, it's all taken care by the big data framework, but this is an important concept to understand. All right. So let me quickly talk about wrapper classes. It's not an important topic though, but I'll quickly cover on this thing. So wrapper classes are nothing but you have primitive data types that we discussed the first day, right? So initially we didn't have this wrapper classes in picture when the initial version of Java was created. So data types were dealt in terms of primitive data type itself. Then since Java is object oriented, right? It has to be completely object oriented. So they came up with a concept that we shouldn't be dealing data types as a primitive data type. Rather, we should be having some sort of object to it, which is wrapper, right? Which is wrapping this primitive data type. So in order to make it completely object oriented, they have come up with this wrapper classes, right? So int, when you define int, right? If you define int something of this sort, it's primitive. Whereas you would have something like this, int I is going to be primitive data type, and whereas you would have something like this, which is nothing but wrapper class, right? So if you go into the wrapper class, you could go into the source code and see it's nothing but it's doing the same thing. It has got some utility methods as well on the top of it, but basically it's storing your value. So for now, they have changed the source code quite a bit. Basically, it's storing in terms of characters, I believe. All right, so you need not take care of this, but what I'm trying to say is wrapper class is nothing but a wrapper built upon the primitive data type so that everything is taken care in terms of classes since it's a completely object oriented programming language, right? So Java has a class dedicated to each of the primitive types. These are known as wrapper classes because they wrap the primitive data type into the object of that class. All right, so you could see for byte, you have a wrapper class, corresponding wrapper class as byte, which starts with capital B. All right, since it's a class, it has to start with uppercase or it has to follow camel casing. Short has again short, int has integer, long has long, float, you could see a corresponding wrapper class with name float, double will have double, character, char will have character, which starts with uppercase C again. Boolean again has camel cased Boolean as its wrapper class. All right, so when it comes to classes, you could have hierarchy. So basically, you could see that all this byte, short, integer, long, float, double, everything is subclassed from number. So basically, in the source code that we saw for integer, you could see it's extending number, right? So that's what it is saying here. It's a subclass of number. Integer is a subclass of number. So how do we use wrapper class? It's basically you just have to pass value to it, or you could have as a part of constructor you could pass some kind of value to it, or so you could either assign value of 100, right? Or you could have something like this. Okay, so you have different variants of it. You could either create it directly, assign literal value to it, or you could have something like this. But as you could see, this is deprecated. This is no longer required actually. It is still accepting it. It's not throwing compile time error, but it's deprecated, which means if you're writing a new code, you shouldn't be writing it this way. So there's also concept of auto boxing, which is nothing but if you have like integer a could be assigned value k directly, all right, or could be assigned value j directly. So it could be converted from wrapper class into your primitive type without any kind of conversion. That is known as auto boxing. It does it by itself. Now, what is generic in Java? Generic is nothing but template in in C++ rather. You define a template which is a general this thing. You're not putting in a specific data type. You are saying that this is what it is. It's a template, and you could have any data type during runtime. So basically, what you're trying to say is this particular method or this particular class is a generic class which could handle any data type that is passed. So it's not specific. All right. So generics in Java is similar to templates in C++. Generic enable type parameters when defining classes, interfaces, and methods. All right. So the type parameter is nothing but a generic type. And it's not saying that it's going to deal just with integer or with character or with string. It is saying that it could handle anything that comes, any type that you would send it, any type that you would instantiate that class with. All right. So when we take example, you should get some more idea about this. Generic provide compile time, type safety, allowing programmers to catch invalid types at the compile time. So generics work on type erasure, which is nothing but which is done at the compile time itself. Basically, it's done at the compile time. It can catch exceptions during the compile time itself, or it could prompt you during the compile time itself. All right. We can specify the type in the Angular brackets. So whatever type you want to do, whatever type is that class going to handle, we can put it into Angular brackets, which makes it generic. All right. So here you could see that there's a method which is print array, which is taking E as type. So as you could see, E is the type here. All right. E is a type here. And we are not mentioning that it is going to take print integer array or string array or something of that sort. We are saying that it's generic. So whatever you pass or whatever you instantiate it with, it's going to take that array and print elements within it. All right. So this method could be thought of as a generic method, right? You could think of this print array as a generic method, not a method which is just taking integer and printing it. It could be string array or it could be anything else. So that's what generic means. Advantages of generics: type safety. Objects of single type can be stored in generics. We would be looking at it in the next example. Typecasting is not required. There is no need to typecast it because it knows that what kind of objects that particular data structure would carry or hold. Compile time checking, it checks type mismatch error in compile time, which avoids runtime errors. All right, so imagine a list, which we are going to talk in further slides. What is list? But imagine a list which is a collection. All right, and you have like, imagine a list which is holding strings. All right, so you have list dot add and you add edureka to it. Now when you get zero, typically get zero would have object. The return type would be object, since it doesn't know that it is just carrying string. Nowhere you have mentioned that it is a string of, it's a list of string, right? It's a generic list, so it could hold integer value as well. All right. So in that case, what you need to do is when you do list.get0, you have to typecast to the string. Yeah, the next element could be integer. We don't know, right? Since we haven't said that it's a list of string. So that's the reason you need to have typecasting done. All right. Now using generics, you could define that this list is a list of string. All right. It's going to carry only string, nothing else it's going to hold. Now it makes it simple, right? You add edureka. Now if you try to, during the compile time itself, if you try to add integer to it, like list.add 100, it would throw an error saying that it cannot hold integer because it's meant for string. So that's the advantage that you get over generics. You could hold it, you could catch errors during the compile time itself. All right. So it won't allow you to add, or it won't allow you to put 100 into your list of string. All right. And since we know it's going to hold only string, there's no need of typecasting it as well. You can see here it's not typecasting it. In this case, you had to put this string here, right? So basically, in this case, you need not typecast it. There's no typecasting required because we know it's a list of string. Now, what are collection frameworks? Collections framework is nothing but you have data structures in terms of classes. Again, it's a wrapper for data structure. All right. It's nothing but like you have array, which is normal primitive arrays, but this one would be sort of growing array. So basically you need not take care of actually, adding up indexes to it. It would automatically, it's a self growable array. So you could imagine when it comes to array, you could imagine collection. You could imagine one of the classes within collection is list, which is nothing but growable array of any data type. All right. So Java collection framework provides an architecture to store and manipulate a group of objects. A Java collection framework includes the following. It has interfaces, classes, and algorithm. Interfaces is nothing but again specification. This is how it should be. So Java says that, when you have a list, it should have so and so methods, like adding to the list, setting to the list, removing some elements to the list, something of that sort. So it defines collection. If you have a collection, you should have so and so methods, and list should have so and so methods, and so on and so forth. So basically, it's for specification. Classes is nothing but concrete implementation. So list by itself would have all the methods that you just the it's an interface, right? So it would have all the methods that you want without any implementation, but this classes would be actually implementing it, or rather it would be implementing these interfaces and would be giving a concrete implementation for methods, right? So as you could read here, it's concrete implementations of collection interfaces. In essence, they are reusable data structures. All right. Algorithm is nothing but there are utility algorithms that you have, like if you want to sort a particular collection, or if you want to sort a list of string, you could do it using your algorithm, using a predefined algorithms that already comes preloaded with Java. All right. When I say algorithms and where are these algorithms residing, there's a class which is collections. So you have a collection which is an interface, top level interface, and you have a collections class which is holding all the utility methods or algorithms, whatever you call. So basically, you could just read through this hierarchy. These are different types of data structures that has been supported by Java. You have a collection. So the top level interface is, as you could see, there's collection which is extending iterable. All right, extending iterable interface. Collection itself is an interface. You have a list as interface, which is extending collection. All right. So list is extending collection. Queue is extending collection. Set is extending collection. So we have three distinct type of data structures here: list, queue, and set. List is nothing but you could say it's a ordered one, right? It maintains the insertion order, right? The order in which you inserted data into the list. Queue is nothing but first in, first out, and whatever you push in first would come out first. And set is nothing but it's a set in mathematical form, right? Wherein you have unique values. You cannot have duplicate values. So that's what set is, but it need not be ordered. It need not maintain the insertion order, right? So you have the concrete implementations for list are array list, which is nothing but again similar to array that we have, right? The normal primitive array that we use. So it's a wrapper class for it. We have a linked list. All right. So this linked list is nothing but doubly linked list. All right. So you could traverse the either direction. You have vector as well, which is legacy form, which is not used to that extent yet as of now. So we have vector, and we have a stack which extends this vector. All right, stack is nothing but last in, first out, and it adds some more capability on the top of this vector, which is nothing but it's a subclass of vector. All right, so these are concrete implementations of list. We have a queue, and as you could see here, there's one interface here, DQ, which is nothing but it is extending queue. All right, and we have a array DQ, which is implementation of DQ. All right, it's a class which is implementing DQ interface. All right, there's a priority queue as well, which is a class which is implementing queue. When it comes to set, we have a sorted set, which is again an interface which is extending set. And as you could see, there's a tree set, which is a concrete implementation of sorted set, and it sorts the element that you put into a set. It sorts it into a specific order. All right. Again, the concrete implementation of set interface are hash set, which is nothing but which does some kind of hashing, which is a default implementation of set and which doesn't maintain insertion order. Hash set is nothing but it is indexed to for fast traversal, or if you want to get something out of a set, it's kind of an indexed set, you could say, right? It has buckets and everything. It follows hashing algorithm, right? Which is basically for indexing, or which is basically meant for retrieving data faster from the hash set, from the set. And that implementation, that's a default implementation, which is hash set. All right, there's a linked hash set which maintains the insertion order. All right, this hash set doesn't maintain the insertion order. So if you put x and y into your hash set And if you retrieve it, or if you traverse through it and print the values, it's not mandatory that you would get X and Y in the same order. Whereas in the linked hash set, it's pretty much you could be 100% sure that X would come before Y. All right, so it maintains the insertion order. What is list? List is nothing but an ordered collection of elements which can contain duplicates. Unlike set, it can contain duplicates, but it has ordered, and unlike set, it is ordered, right? Lists are further classified into following: array list, linked list, and vectors. All right. So based on the use case, you could select one of these data structures. Let's talk about array list. Array list is nothing but similar to arrays that we had. And here you could see elements stored within of size 5, array list of size 5, and you could see values stored within. All right. So this is how you instantiate an array list. Array list object is equal to new array list, and you have an array list created. One of the main things about array list is, as I said, it's self-growable or it's dynamic. You, unlike array, the normal primitive array, wherein you had to, within your square brackets, you had to mention the size of the array during the declaration itself. Whereas in array list, you need not have to mention this size. All right, it grows by itself. As in when you insert data into it, it would grow. So basically, you could imagine in general scenarios, or in most of the programming cases, or in most of the real use cases, you don't know upfront what is the size of data that a particular array is going to hold, right? Or the number of elements that a particular array is going to hold. You cannot know it upfront because things are dynamic, right? So suppose you are reading from the database, you don't know what that size of the data, or what are the number of elements that a particular database is going to have. So typically, you could imagine real cases, you would go with array list and not primitive arrays. All right. So also you could imagine this is saving us in terms of memory, because we are not hard coding the values of it. So by default, it starts with 10, size of 10, and then it keeps growing as and when you insert it. So again, it has a logic. It doesn't keep growing for each and every insertions that you do, but it has a logic within to grow it by a particular size. So which is all optimized, which is good uh, for your cases, use cases. So these are the methods that we have within array list. It's pretty straightforward. When you do add, it happens the specific, it's usually add and not collection. For collection, you have add all methods. So it's a typo here. You have add, and you mention an element that you want to insert into a list. If it's a string, you would have string element, or if it's something else, if it's an integer, you would have integer element. You could add it to a particular index. You could clear it, removes all the elements from the list. You could have last index of, okay, return the index of this list of the last occurrence of the mentioned object. So if you have multiple, as we said, there could be duplicate values within, but when you give last index of, it's giving you the last index. All right, last index of the object that's been passed. You could clone it. So it's basically coming, clone is nothing but a method that's there within your object class, and it would shallow copy the array list. So whatever list you have, there would be a clone of it, right? So clone is, as we could see, it's from the object class. So any class that you create could be cloned. All right, then you have two array. So you could have an array list, and if you want to convert it into a primitive array and use it in some form, you could do that thing as well by doing two array. You could trim to size. So trim to size is nothing but trims the capacity of this array list instance to the list's current size. All right, so whatever is the size, it would trim to that. So moving on, let us understand how we can traverse through a list of collection. So traversal is done through iterator interface. Okay, so basically you have an iterator interface, and that's how you traverse it. Basically you have implementations of it. Since it's an interface, it is just a specification. You would have an implementation of it. So iterator is an interface that iterates the elements. It is used to traverse the collection, access the data element, and remove the data elements of the collection. All right, it's used for traversal as well as removal of data elements within the collection. Okay, so what are the methods that we have within iterator? First is has next. So it's nothing but, as you could imagine, it is returning Boolean. So if it has a next element, it would return you true. Okay, and if it doesn't, then if the array list is already exhausted, then it would give you false. So you would basically you would have a loop wherein you would see if it has a next, right? And if it has next, you could access the next element using next method. All right, so next would return the actual object. And to remove it, you could do iterator.remove, which removes the last element written by the iterator. All right, so here you could see how iterator is being used. You declare an array list and you iterate through it and you print the elements. So quickly we can take this. So basically I do com dot edureka dot I create one more package now for array list. Okay, I say collections demo dot array list. All right, so I have this particular class created. Now I create a main method and I create private void. I write a method which is create array list for demo. All right. As you could imagine, when I say create, it's going to return array list. All right. We want it to return list. Okay. What I do here is I would create list, and this list is going to be list of string. Okay. Imagine generics that we spoke about. You're saying that it is going to be list of string. Now it's throwing me error saying which list I want. It's going to be java.util. So you could see java.util.list here. Now I say it's strings.new array list. You're saying that here what we are doing is we are instantiating. So we have a list of strings and we are instantiating it. Since we want array list, it's going to be array list. So here you could see array list being imported as well. All right. Now what we are going to do here is we are going to add some values to it. Strings.add, or maybe I'll put, again, since we have been talking about cars and bikes, I'll cars, right? So we are creating here cars, list of car. All right. So I put BMW. I would put all right. So all German cars, and then we return it. We are returning this. So we are creating a collection, right? And we are inserting data into it and we are returning it. All right. So this would create a list for me. All right. Now I want to iterate this list. Okay. So I create a private method which would return void and which would print array list for demo. All right. So as you could imagine, this is going to take a list as parameter. All right. List to be printed, or it's pretty much implicit or implied that list is whatever list you pass as a parameter is going to be taken for printing. Okay. So here what I would do is list dot iterator. I take the iterator. Okay. So I get the list iterator. I say iterator and I would say list iterator. All right. So I take this list iterator and I say list iterator while it has any elements within. So how do we check with whether it has elements within is nothing but dot has next, if you remember. While it has any elements within, what we are going to do is we are going to print the value in the list. All right. We are going to print it using iterator dot next. Okay, so I've created two methods. One is create array list for demo and the other one is print array list for demo. Create array list is doing nothing but it's creating a list and it is returning the list. And print array demo is printing the list that you have passed as a parameter. Okay, so I create a new element of array list demo dot create array list. All right, and whatever array list that I get, or whatever list that I get, I would be putting it here. All right, now I create one more this and I print it. All right, now when I print it, I'm going to pass this returned array list. All right, I think it's pretty clear now. So we have created array list in this method and we have returned it. And in the second case, we are just going to print it. We are going to take any array list and we are going to print it. All right. So let's see. So rest of the collections, most of the collections, you do it pretty much similarly. It's just that, it's used for different use cases. All right. I am getting some error, I think. Okay. Yeah. You could see here it has printed BMW, Mercedes, and Audi, which we had put into the array list. All right. So that's how you kind of iterate through it. Similarly, you could just remove it. You could use list iterator dot remove will remove the current element that's been iterated. All right. So yeah, basically I don't need to actually create one dot remove. You could remove it. All right. So that's how you remove it if you want to. So you have the same syntax. So basically we don't use iterators nowadays more. It's more about we have Java 8, there are different constructs like we have lambda expressions and stuff. We have streams, stream processing. Basis is you have iterators. All right. So this is what we have. We have an iterator which is iterating through all the elements, right? And you could remove it as well using the iterator. Usually nowadays we use Java 8 streams, which helps us to iterate through, which is pretty much like the underneath is iterator and stuff, but there are some kind of abstractions done so that we don't actually deal with iterators. There's some kind of abstractions or it's less verbose. In this case, you have to write a lot of code to print through and everything. Whereas in streams, it would be just one method call, which would do a lot of things, right? So that's what is being used as of now, but this should be good enough to start off with to understand the basics of it. All right. Other thing is I was talking about the best practices. So it's good to have things broken down in methods so that could reuse it rather than putting everything into the main method, which makes it difficult for any other developers to understand more. So basically, it's a good practice to make it modular, right? And which enables reusability as well, which reduces the lines of code within your program. So tomorrow, if I have some other list which I want to iterate, I can just pass the list to this and it would iterate and give me the result. So I don't have to write the same piece of code again. All right, so moving on. So we have an array list. Array list is nothing but an abstraction done on a primitive array. So what are the advantages of using array list? It's more about it's faster in terms of retrieval, right? Index based retrieval. So suppose if you want to get to the index 2, just write like array list dot get 2 and it would give you the one at the index 2 or the element at the index 2. Whereas when it comes to insertions and deletions, if you want to insert a particular object at index 2, what it has to do is it has to move that was there at the index 2 to the index 3 and it has to increment the entire array by one or move to the right by one position, which is pretty cumbersome, right? Which takes a lot of time. So insertions and deletions are not good when it comes to array list, whereas when it comes to retrieval, it's faster. So based on the use case, you have to decide which data structure you should go for, right? So simply put, if you think of big data applications, it's mostly about you don't have insertions and deletions as such. It's not transaction, right? A typical online transaction processing, this thing would be application, or say for example you have Amazon, right? Amazon or something wherein you have a lot of transactions happening which needs insertions and deletions, right? In that case array list is not a good option. Whereas in terms of big data, which is like analytics, right, online analytic processing, which doesn't have transactions as such, right, it doesn't have insertions and deletions, it is one time load. You have data, you load it into your data structures and you do some kind of processing or you do some kind of analytics on this data, but you don't manipulate this data. You don't actually have insertions or deletions done. In such cases, it's better to go with array list. All right. So which is the variant which is good for insertions and deletions? That is linked list. All right. When it comes to insertions and deletions, and you want to maintain the order of the list, insertion order of the list, that's when you would go with linked list. All right, so linked list is a sequence of links which contain items. Each link contains connection to another link, and that's how insertions and deletions are simpler. You don't have to shift elements to the right when you insert it, or you don't have to shift elements to the left when you delete it. There are two types of linked list to store elements: singly linked list and doubly linked list. Singly linked list is nothing but it has pointers in one direction. Doubly linked list is like it has previous and the next. It stores both. Each node would store previous element, pointer to the previous element, and the next element. So yeah, this is a singly linked list wherein you see that it has pointer to the next. It doesn't have pointer to the previous one, right? It's a one directional traversal, right? Whereas in doubly linked list, you could see that it is looping back to the previous element as well. So it has a pointer to the next and it has pointer to the previous one. It's a bidirectional traversal. So linked list has pretty much similar to array list. You have add. You could add a particular object. You could check whether a particular object is contained within the linked list, and that object has to be passed as a parameter to contains. You could add a certain element at a particular index. You could add it to the head of the list. You could add it to the last. You could check the size of the list. You can remove the element from the list, and you could get the index of a particular element. So you could pass some element and get the index of it. Since linked list is again, it can have duplicate elements. If you want to get the last index of a particular element, you could do that thing as well. So if you have multiple elements, you would get the last one, right? The index of the last one. So linked list example here, you could see that a linked list of string is being created and you add values to it. Rachit, Rajul, Rahul, and Rajat. You add things to it, and yeah, this is just about adding elements to the list. All right. So array list versus linked list. Array list internally uses dynamic array to store the elements. Since I said it's growable, it grows on its own. Linked list internally uses doubly linked list to store the elements. To add an element in between or to remove an element from the array list is slow because it internally uses array. If any element is removed from the array list, then the rest of the element should be shifted to the left. All right. Similarly, when you add something to the list, you have to move everything to the right. Adding an element in between or removing an element with linked list is faster than array list because it uses doubly linked list. So no element shifting is required, right? You don't have to shift any addresses or something. It's just about moving the pointers, right? So you would just move it, skip one element and move to the next in terms of deletion. Whereas in terms of insertion, you would insert a node and you would manipulate the pointers accordingly. All right. Array list can act as a list only. It is normally for list, but linked list could be thought of as a list as well as queue, right? Since it's a doubly linked list, you could have like first in, first out. Array list is better for storing and accessing data. All right. So as I said, this is pretty much good enough for analytical sort of application, analytical nature of application. Whereas when it comes to transactional, linked list would be better. So linked list is better for manipulating data and it is slow in searching an element because it needs to compare the elements from the first node. When it comes to, index based search, it is slower because it has to start all the way from the start because it goes through links, right? It has links linked to next element and that's how it traverses through. Vectors are similar to arrays, but it's a legacy form of it. It's a dynamic array again, similar to array list. All right. It could be visualized very much similar to array list, but just that it's a legacy of Java. It's not used to that extent, or I would say it's not used at all at this point. But what is important to note is vector is synchronized when it comes to multi-threading. It's better to go with vector, but nowadays we have concurrent array list that is supporting concurrency, right? So there are a lot of optimized versions of it, which gives a lot of performance improvement. So vectors are no more used as such in industry. It's a legacy form of array list. There are concurrent versions of array list that has been evolved, which could be used in multi-threaded applications. All right. Vectors contain many legacy methods that are not part of collections framework. So it doesn't even fit into collection framework because it contains some legacy methods which are no longer used or which are not part of collection framework at all. Now vector is again taken into collection framework and it implements list, and that's the reason it has the implementation for these methods, because these methods are typically coming from collection and list, collection interface and list interface, and all the concrete implementations have to implement it. And since vector is one of the concrete implementations of list, they have to ensure that they implement these methods as well. All right, so these are the methods pretty much similar to what we spoke earlier: add, clear, and add to a particular index, remove, and then you could have size, then you could have last index of and last index of object. So it's a vector of string, then you add element, you add Umesh, Irfan, and Kumar, and you just iterate through it to print out the message. Umesh, Irfan, and Kumar would be the output of this application or this program. All right, so you could see iterators used here as well, like we did it in list. So let's talk about queue. Queue is nothing but first in, first out. Whatever goes in first would be first to come out. A priority queue allows you to initialize a queue. These are implementations of queue. So you have a priority queue. You have, as we said, linked list is list as well as queue. So you could have linked list assigned to a queue, right? Linked list is a list and linked list is a queue, right? Is a relationship, which means it's extending it, right? So here we can see double-ended queue lets you to add or and remove. So double-ended interface DQ interface allows you to add and remove elements from peak as well as from the bottom. That's what DQ is, double-ended queue, right? And array DQ is nothing but the concrete implementation of DQ. DQ is an interface and the concrete implementation is array DQ. So what are the Q and DQ methods? You have add method, which is nothing but it adds to the top of the queue and it returns boolean, as you could see here. If it is successful, if it has added to the top of the queue, it would give you true, and if not, then it would give you false. All right, you have offer, which inserts the specified element into the queue. Again, it does the similar stuff, it inserts to the queue. All right, you have remove, which removes the head of the queue. We have poll, which retrieves and removes the head of the queue. Again, it does the same thing, retrieves and removes the head of the queue and returns null if the queue is empty. All right, polling is nothing but getting the top of the queue. And you have element, which retrieves but does not remove. All right, so when you do queue.element, it would give you the top of the queue or the head of the queue, but it would just give you, but it would still be there. So if you want to check value that is on the top of the queue, if you want to check it and do something with it based on the value that is there on the top of the list or top of the queue, if you want to perform some actions, you can do it using element. Peek again does the same thing, it retrieves but it does not remove the head of the queue. If you want to actually retrieve and remove the head of the queue, you would either use remove or poll. Basically you would use poll, not remove, right? Remove is not a good operation to do when you want to retrieve and do some actions on it. The best practice would be to use peek to retrieve and use poll to actually retrieve and remove. All right, so let's take an example of queue. So right here in the package, I create a main method, right? So I create private queue, create queue for demo. All right, so it's asking me which queue. I'll go with this one, which is java.util.queue. All right, now I'm creating a new priority queue, which is a concrete implementation, which would be, say, for example, of integer, right? So I create queue of integers. So we are putting integers within, all right? And what we are doing is new, I am instantiating it, all right? So this is a queue which is going to hold just integers. That's where generics come into picture, right? Queue of integers dot add, suppose I put 100 and then I put add is used to, as I said, to insert, right? And I put 50. So I've created a queue and I return this queue. So I've created a queue so far. Let me print this queue. All right, so we have, which is going to return void and print queue for demo, and which is going to take queue. All right, queue of, say, I'll not even put it here. So now let's see how we can retrieve elements from it. One way is to iterate through it, and let's see how poll and other things work, right? So let me get the head of the list. So this is just retrieving it, right? Retrieving head of the list. We are not removing it. It is still there in the queue. We are just trying to check what it is. So when I say when it's retrieving, it's peak. All right. Now, if I want to remove it, if I want to kind of retrieve and remove it. So basically what I'm trying to say here is when you have queue.peak, it's going to return the top of the list, which is nothing but 50. All right. So the first one, the peak is just retrieving it. Whereas when I poll it, it's going to retrieve and remove as well. So I have queue.poll is going to, now when I do s out, retrieve and remove, say this is the first attempt, all right, and we again do it, which is the second attempt. This is just to show you that when you poll it, it's actually removing it as well, whereas peak is not removing it, all right. So peak is just retrieving it, and this one is removing it. So the first poll is going to give you 50, whereas the second poll is not going to give you 50, it's going to give you 200 because it has removed 50 from the queue. All right, so this is what I wanted to show. So let me queue demo. All right, so here I'm going to do demo dot. So when it comes to generic, we can make this a generic queue program by doing something of this, and instead of hard coding it, you could put as T here. Right now, let's keep it as is. All right, so in the first case, queue is being created. The second case, we are going to see how peak and poll works. Retrieving is just retrieving it, and it is still keeping that element at the top of the queue, whereas polling is actually removing it as well. All right, so you could see here, peak is giving you the last one here. It's a double-ended one, so it's giving you the last one here, and poll is giving you this one. It's based on priority, I think. All right, so you can see poll is giving you 50 as well, and when you poll it again, it's giving you 100. All right, let's move on to the double-ended queue. All right, so here we have something like you could remove first. All right, so it's a double-ended queue. You could interact in both the directions. You could actually remove first and add to the last and stuff like that. So you could see here that there's a double-ended queue created with 4 elements initially, 21, 42, 63, and 84. And you could see that remove first is removing 42, 21 rather from here, since 21 is the first one. So it's removing 21, and remove last or add last, it's adding to the last, which is nothing but it's adding 105 to the last. So what is set? Set is nothing but, as we said, it's a representation of mathematical set, which is unique, which holds unique values, right? You cannot have duplicate values within set. Set has its implementation in various classes such as hash set, preset, and linked hash set. So it's a mathematical set abstraction. We have variants of set in Java, which is hash set, linked hash set, and tree set. Hash set is nothing but it hashes it, or basically there's this indexing done. And it's good for retrieval, as you could imagine, since it's indexed, it's good for retrieval. Okay. So the analogy behind this could be, or it is analogous to index page that you have in books, right? You have index page, you just go to the index page and see at what page is the content that you are looking out for. This one is pretty much similar to that. So when you do hashing, you would be able to retrieve it much faster than sequential retrieval. All right, so that's what hash set does, and it has unique values, of course, which is a property of a set. You can't have multiple values within or duplicate values within. It doesn't sort automatically. This is a typo here. Hash set doesn't maintain any order at all. It's internal to the order in which the retrieval would be done is pretty much internal to the runtime. Or what I mean to say is, if you have a hash set with the same content and if you run it multiple times, you would see that the retrieval is different in different instances. So it doesn't maintain any order. Your application might demand something or demand a data structure that is set as well as it maintains the insertion order, right? That's a scenario in which you would go with linked hash set. So linked hash set is nothing but set which has its insertion order maintained. All right. So the third one is tree set, which is nothing but it. So these are the methods that gets inherited into hash set and not similar to other collections that we have, but just to talk about this one. So you have add, which is just adding object into hash set or linked hash set. You have contains, which is basically checking whether a particular object is present in a set. You can clear the contents of the set. You can check whether a set is empty using isEmpty method. You can remove a particular object from a set using remove method and pass the object that you want to remove. Clone is nothing but a method that is inherited from object class, which is superclass, and it is basically meant for cloning any data structure or any class or any instance of a class. All right. So when I say cloning, it's not but making a copy of it, and it's a shallow copy. There's a deep copy and there's a shallow copy. Shallow copy is nothing but the properties within the set, so the references remain the same. Basically, you would have a value, say for example, string, right? If you have a value, say edureka, you would basically have both the set pointing to the same instance of edureka. All right, so it's a shallow copy, and deep copy is wherein you would have different instances altogether. So when a change is made in new set for a particular element, it won't be reflected in the other set. So that's deep copy. But by default, it's a shallow copy that's done. If you want to deep copy it, then you'll have to use some other utility or use some other class. All right. There's an iterator similar to other collection. You can have iterator to iterate through the set, and if you want to check the size of the set, you could use the size method. All right, so let's see an example of hash set and linked hash set. All right, so here I have created two methods. Create hash set, which creates the instance of hash set and adds some integer values to it, which is 130, 340, and 440. And you see there's one more method created, which is create linked hash set, which is again inserting three elements into it, which is 100, 300, and 500. So I return this. All right, now I write a method to iterate through it, which is displaying nothing, and print set, and which would set s. All right, what you do is you have like set to print dot, you could have iterator, right, which would give you a iterator, which would give you an instance of iterator for set. All right, so we have an iterator created for set. Now let's iterate through it. So remember how we iterated list. So you would say set iterator dot has next. If it has next, then print the value of. So basically we have this, then you have set iterator dot next, which would give you the actual value. All right, so we have a method which would iterate through the set and display its content. All right, now what I do is I create instance of set demo. I create hash set, and whatever value I get, I put it as hash set for demo, or I keep it as set. All right. Now I have again set. I say linked hash set for demo. So basically we just creating the set. All right. Then we create the linked hash set. Now set demo, we are going to print it. The first one to be printed is hash set for demo. And this is what is reusability, right? See, I'm not writing the method to print it multiple times. It's just once, and which could be used for printing hash set as well as linked hash set. So this is what reusability is all about. If you don't expose it as a method, and if you write it within your main method, you won't be able to reuse it, and you would have to write the same piece of code multiple times, which adds to the redundancy and which is not a good practice. And this also makes it much more readable. By looking at it, you can understand that, okay, it's creating a hash set, the second method is creating a linked hash set, and the third one is printing a set. So it makes much more readable, right? So that's an important factor as well when it comes to programming. All right, so here we can see that when I printed the hash set, it gave me 133, 44, 40. Now the thing is, it's just 3 elements, so it has maintained the insertion order. But basically, if I have more elements, I'll just copy this multiple. Oh, okay, I remove this. Okay, now you can see that you won't get it in an insertion order since it was just 3 elements. It's by fluke that you got it in the same order as which you inserted. So if you see it now, so now you can see that, the first element that got retrieved is 4401, which was basically you put it at the last, right? So it's pretty much random. As I said, linked hash set, the retrieval would be pretty much random. You could see 4401, then 130, which was the first element inserted, then 340, then 440, then you saw 40, which is again out of order. So basically, this is what linked hash set does. And suppose I put the same values in the linked hash set, you would see that insertion order is maintained. All right, so from here, if you see from 130, I think from here it's printing linked hash set, and you could see the insertion order being maintained as is 44, 10. And when you see hash set, which is pretty much like this one, you can see that it's random. All right, so that's what linked hash set and hash set differs on. Tree set is nothing but it's a sorted set, and you have a retain all method. Retain all method is nothing but intersection between two sets. So basically you could pass one more set to the retain all method, and you would get an intersection of two sets. So what I mean to say is, if your set has value 1 2 1 2 3 4, and you pass one more set to it, or you invoke retain all method and pass one more set to it which has values 1 and 2. All right, so your source set on which retain all method is being called, that has got 4 elements, 1 2 3 and 4, whereas the set that is passed to retain all contains only 2 elements, that is 1 and 2. All right, now when you invoke it, your source will have only 1 and 2. Your 3 and 4 would be removed off from the source set, because the retain all method is nothing but it's an intersection between two sets. Okay, so size and hash code, so all these methods remain the same as other ones that you have in different collections, right? So you have like size, which would give you size. Hash code is nothing but a unique integer that's written for any object in Java. It's not just preset. Any object in Java, when you invoke hash code, it would give unique integer. All right, because this particular method is inherited from object class of Java. Contains is nothing but pretty much similar. You pass an element and check whether that element is contained in the source set. Contains all is something like retain all. It would return true only if all the elements in the collection that's passed here as an argument is present in the source set. All right, it has to have everything, all the elements. So in the previous case wherein I said the source has 1 2 3 and 4, and if you do collect contains all on a set, or you pass a set to contains all with values 1 and 2, it would return true. Whereas if you pass a collection with values 5 and 6, it would say false, because you don't have values 5 and 6 in your source collection. All right, iterator is nothing but it returns the iterator that we checked on. You can convert it to two array. Any collection could be converted to two array, which would give you object array. You could check equals, basically checks if the collection is, I think it has to be empty here. it checks whether your collection is empty. So there's a typo here. Just to give you an example, I'll create one more. So I copied the same method and I said create tree hash set. All right. So what I do here is I'll make these changes. I'll keep it as, this could be kept as set, and this is like tree. All right. So tree set, and we are set. Now I print this one. Okay. Basically set demo dot create tree hash set. All right, so I'm printing this. So prior to that, maybe I'll put a statement here, printing tree set. All right, so I created a tree set with this random values 130, 340, 440 and stuff like that. Now let's check whether it has sorted it or not, right? So I created a tree set and I'm just printing it here. So what you can see here, we have created tree set. Now, if you see it right after printing tree set, all the values that you see here, 10, 30, 40, 44, 130, 440, it's all sorted if you see, right? And it's unique as well. So if you insert it multiple times, like if you insert 10 multiple times, still it would take just one value of 10, all right? So you cannot have multiple values. If you put 10, unlike array list or linked list, which will have multiple values, this would take just one 10. All right, it would ignore the other one. Enum set is a special type of set which creates, enum is nothing but a constant. It's a replacement for constant in Java. So basically it's a replacement for public static final, and basically for constant, earlier it was like we used to use public static final, but now it's advisable to use enums for constants. All right, we'll see an example which would give you much more clear idea about it. So first one is all of. All of method is nothing but creates an enum set containing all of the elements in the specified element type. So it would create a enum set with all of the elements that you have. Copy of is nothing but creates an enum set initialized from the specified collection. All right, so you could pass a collection and it would create an enum set out of it. None of is creates a empty enum set with the specified element type. There's creates a enum set initially containing the specified element. Okay, you could initialize it as well. So basically here we are giving a specific class with which it would be created, or the enum set would be created. Range creates a enum set initially containing the specified elements, right? And clone is nothing but, again, it's pretty much similar. As I said, clone is a method that is inherited from object class and is meant to clone or have a shallow copy of the data structure against which it is invoked, or object against which the clone method is invoked. All right, so here we can see there's a enum which is months. All right, so here you could see a enum months which has like 3 months declared within Jan, Feb, and March. All right, so now what you do is enum set off, and you just create set out of two of these elements, which is Feb and March. All right, so this is what enum off is. So you could have some enum values put in and it would create set out of it. Now when you iterate through it, you would see that you have Feb and March into your enum set. All right, so this is something that is required when you have enums with multiple constants, and if you want to have, or you want to create set out of it and do something with it, right? So it would be pretty much common, or you imagine of enums as an exhaustive list of constants, right, which is used throughout your application. Now there might be instances wherein you want to put them into set and do something with it, right? So basically this is meant because the values within your enum cannot be put into a data structure as of now, or prior to enum set we were not able to put the values within the enums into a data structure, right? It was considered as a separate entity. So now this is introduced so that you could put it into a data structure as an object and you could play around with it. So that's the reason we have enum set. What is map? Map is nothing but it's a key value pair and it is unique keys. It holds unique keys. So suppose if you try to insert same key with different value, you would have your value updated or overwritten with the new value. All right. So, but it won't duplicate it. So what I mean to say is it maintains a key value pair, but the key is going to be unique across. All right. So this could be imagined as a table, right? You have a table in data structure which has got one primary key, say employee ID, and there's a name which is like name of the employee, right? Imagine this ID is a primary key, right? So you cannot have multiple values. So if you try to put one more value to it, it won't allow you to put in. The only thing that you could do is update the value of existing IDs or add a new ID. So this is pretty much similar to that, right? Map is specifically for maintaining key value pair and wherein keys would be unique. And if you try to map an existing key with a new value, you would see that the value is being overwritten, but you won't have duplicate keys. All right. Again, there are different variants that we would look at. Map has hash map, which is similar to hash set, which is based on indexing or hashing. All right, you have linked hash map, which is pretty much similar. Again, hash map doesn't maintain the sequence of insertions. Linked hash map maintains the sequence of insertions. There's a sorted map, which is again tree map and which is sorted on based on keys. All right, so the structure that you see here is pretty much similar to set, right? We had hash set, we had linked hash set, and we had tree set. So this one is pretty much on the same lines as set. So how do you put data into your hash map? It's with put method, right? You have put method and you put some key and value. All right. We have put all. We can have an existing map, and if you want to put all the key value pairs that's there into a map, into a new map, you could use put all. Or you could remove some key, you could get some key. All right. You could check whether a particular key is contained within hash map. You could get your key, all the keys in the hash map as a set, which is key set. Just give you extract all the keys as set, and as they are unique already, then you would get a new set returned out from key set. Entry set returns the set view containing all keys and values. So basically you would get all the keys and values as a set when it comes to entry set. From the entry set you could get key and value distinctly. All right, so get key is nothing but obtain a key, get value would give you a value against the key. Now, what are the typical exceptions that you get when you deal with map? Some exceptions thrown while using map interface is no such element exception. So when you're trying to invoke some item from the map, if you're trying to invoke a key that doesn't exist, this is what you would get. Okay, this is more about when there are no items, if there's no item that exists in the map at all. If it's an empty one and if you're trying to retrieve something, that's when you would get no such element exception. All right, class cast exception is pretty much it's a generic exception that you get when you try to cast it against an object, or suppose value is a string, all right, and if you try to cast it to integer, you would get a class cast exception since string cannot be mapped into integer. All right. Null pointer exception is the runtime exception, which we saw that if you haven't